So here's the deal. Something is bound to happen that can affect everything we've ever known about space and time. You've heard of black holes, right? That denser-than-life type of phenomenon that usually exists in the center of galaxies. Two of them, located 9 billion light-years away from Earth, are expected to collapse into each other, and oh my, I do not want to be around to see that. Let's get one thing straight. Black holes are the most powerful things in the entire universe that we know of. If they decided to go all Revenge of the Sith on us, we'd be doomed. A black hole was once a massive star that went supernova, meaning that the star collapsed onto itself, and the sheer magnitude of the explosion created a black hole in its place. By the way, black holes do not pull things inside like a vacuum cleaner. That's just a popular myth. Say we were to replace our sun with a black hole at the center of the solar system. Not much would change, except that maybe we'd all freeze. But black holes can do something much worse than vacuum stuff. They can delete the universe itself. If a black hole was to follow a normal timeline, it would go from its creation to total disappearance. But this process is very, very slow. I'm talking billions and billions of years before a black hole loses its mass entirely. That happens because they are constantly losing their mass, every single second. Black holes radiate their mass away, like a boiling teapot loses its water as steam. Yet, things rarely go as planned, both in our lives and apparently in the universe itself. So it wouldn't be that much of a surprise to find out that two black holes are en route to collapse. That's what scientists have found out recently. And let's just say that this is one of the reasons why the scientific community is freaking out just a little bit. The first question that comes to mind is, what does that mean for us humans? Total annihilation? Now. No need to be this dramatic. The best case scenario, we'd be in for an interstellar type of experience. Roll me in, please. Let's rewind a little bit to understand how this would happen. 45 years ago, a group of scientists began noticing a weird behavior coming from a galaxy far, far away. The galaxy is found 9 billion light-years away, and its scientific name is a mouthful, SDSS J1430 Plo2303, but let's just call it Super Far Away Galaxy. You might be asking yourself, how did scientists observe this black hole so far away if it doesn't emit any light? Good question. That's because black holes gather disks of gas around them, and they emit some of this material into space. These jets can be detected from a distance of millions of light-years. Now, if these hot gas jets are directed towards space, then scientists give these black holes a special name, blazars. A particular blazar has been gaining worldwide attention recently, the PKS 2131021, long name, but let's just call it Andy. Imagine you're a scientist at Caltech, and you're looking at a blazar in your radio telescope, and you notice its strange behavior. Its brightness goes on and off, like the ticking of a clock. At first, you don't understand what's happening over there in a distant corner of the galaxy, but then you realize that there must be another black hole circling the first one. In other words, scientists discovered that Andy was being orbited by another blazar, Gomer, and the regularity of their twinkling can only mean they are close to a total collapse. It gets worse. Each of the two blazars is estimated to be a few 100 million times the mass of our sun. Have you seen our sun? It's huge. It's already 333,000 times the mass of our Earth. This means we're destined to face something out of our league. This is not the first time scientists have detected something like this. In September 2015, the LIGO Observatory detected a collision of two black holes. Each of them was as heavy as 30 suns, and an equivalent of 3 solar masses was released once they crashed into each other. And guess what? This gravitational wave passed through Earth at the speed of light, but we weren't really affected by it. Maybe you were sleeping and felt something weird in the air, but nothing significant happened to us as a species or to our planet. But that's because the blast was weak. The thing is, the expected collision between Andy and Gomer will send unprecedented gravitational waves throughout galaxies. And they will reach the solar system. But what is this shockwave actually capable of doing? It could stop our sun from releasing gas for a few minutes, which means it would stop heating the solar system. So, let's say you were going about your summer day, and out of the blue, the atmosphere froze for a few seconds. Doesn't sound too nice, huh? But that's actually a better possibility than the next one. In one of the worst-case scenarios, the blast from the collision between Andy and Gomer could break bonds between atoms and make everything disintegrate. You, me, your cat. We'd all turn into tiny particles floating in the vacuum of space. This may sound scary, but scientists say that an atom is made out of 99% empty space. This means that everyone on this Earth, all 8 billion of us, and everything that exists, plants, objects, animals, are all made up of 99% empty space. So perhaps all that Andy and Gomer would do is separate all of our atoms and desolidify us. Then again, the blast could mess with the fabric of space and time as we know it. You remember Albert Einstein, right? Crazy hair? He's the name behind the theory of relativity. Einstein discovered that time is relative. It is always dependent on the observer. This would mean that time is not the same throughout the cosmos. Why though? Well, because Einstein's theory of relativity is also a theory of gravity. Einstein discovered that gravity is the effect that objects have on the fabric of space-time. Every object that has a mass, including me, you, your cat, and our planet, creates a warp or distortion in the fabric of space-time that causes it to bend. The bigger the mass, the bigger the gravitational force, and the bigger the distortion on the fabric. It may sound complicated, but hey, this is what creates different perceptions of space and time throughout the cosmos. This is why you'll age differently on Earth and on Jupiter. This is why time passes completely differently for astronauts on long missions and for people that remain on Earth. And this is why a collision of two megablazars could mess with our perceptions of space and time, due to the sheer force of its gravitational shockwaves. Got it? Not to mention that black holes are already a huge warp in the fabric of space-time. You remember that interstellar scene, right? Where the lead character bends the space-time continuum through a black hole. Don't try this at home though. As far as we know, anyone who chooses to go inside a black hole has no guarantee of making it home again. Scientists say that this blazer explosion will happen in approximately 10,000 years. But wait a minute, if this blazer lies 9 billion light-years away from Earth, it means that these two black holes should have already collided long before our solar system and home planet were born. You see, the solar system was born just around 4 billion years ago, and since it takes us 9 billion light-years to receive the light emitted from the blazers in the first place, this means that the collapse of the two blazars already took place, and that it will reach Earth 10,000 years from now. This means the shockwaves are already making their way through the galaxies at this very moment. But still, it's something not even your great-great-great-great-great-grandchildren will be around to see.
It's hard not to wonder if there's another form of life out there in the universe when you, at the night sky. There's this thing called Fermi paradox. It basically says this: if civilizations that might live somewhere out there in the universe are so common, why haven't we found any signs of them? We've looked really hard, but we haven't stumbled over any proof there are other forms of life somewhere in space, and we suspect there could be many civilizations, because scientists have calculated there are possibly billions of habitable planets in our galaxy alone. So it would seem reasonable to assume that some of these planets could have developed intelligent life, possibly even civilizations that are more advanced than ours. So, Fermi paradox basically asks, where's the party? How come we weren't invited? See, and one of the potential answers to why we haven't found any other form of life in the universe is something called the Great Filter Theory. This theory appeared in the 1990s, Robin Hanson, 1996. And it says there's a big obstacle or challenge that prevents life from being widespread in the universe. It's called the Great Filter because it suggests that there is a filter that most, if not all, civilizations must pass through in order to become really cool and advanced, like the ones from science fiction movies. But so far, there are no signs of other civilizations like that, or even some real evidence of any form of life. Maybe it's really hard to evolve into a complex life form, or maybe it's really hard to develop the technology to travel through space. Either way, it sounds like a tricky obstacle all intelligent civilizations may face. the one that doesn't allow them to make any progress beyond a certain point. It means they might have come to a certain level of development, and then something happened that destroyed them, like an asteroid impact or an environmental disaster, or they could cause their own demise, and bam, everything they've achieved is gone. So the Great Filter suggests there's some kind of obstacle that stops intelligent civilizations from becoming advanced enough to make contact with other civilizations or colonize other planets. This theory presents two interesting scenarios. The first one says that the filter lies in our past and that we have already overcome it. This would mean we have passed the hardest phase and the test in general. Woohoo! But it would also mean that intelligent life is relatively rare in the universe, and that we may be the only advanced civilization that exists at the moment. So the universe could really be relatively empty when it comes to intelligent life. That means the chances we'll make some friends from other planets and visit them in our super cool spaceships are low. That's sad, but the second scenario is a lot worse. It states that the filter could actually lie in our future. We haven't faced this mysterious and pretty advanced test yet. That means there's still a chance for us to fail. If the filter really lies in our future, it may mean that there are many intelligent civilizations out there, but they are all struggling to overcome the same obstacles that we could face sooner than we think. They may be trying to pass these tests, stay alive, and send us a message that we're not alone and that they would like to visit us too. One of the things the Great Filter theory talks about is the development of artificial intelligence, AI. As AI technologies become more advanced, it's possible that it could pose a threat to humanity or lead to unwanted consequences if we're not careful enough with it. There's still hope though. Not everything is so dark and gloomy. Maybe some civilizations have already passed the Great Filter and are out there in the universe, and they'll manage to send us a message. Maybe a life form that is still not bigger than bacteria is somewhere out there, and they haven't come to the level where they're developed enough to communicate with us. Or maybe we'll be the ones to pass the test and send a message to others one day. Either way, scientists are not giving up. They will keep looking for traces of life all around us in space, especially in our solar system. And some of their discoveries tell us we may not need to look beyond our own neighborhood to find signs of life. First, there's Enceladus, a small moon that circles around Saturn. In the beginning, researchers believed it was just a plain rock covered in ice. But in 2005, NASA's Cassini spacecraft took photos of geysers of frozen water that was spewed from cracks in the southern part of Enceladus. One of the most likely explanations is that there are oceans of liquid water lying under the frozen surface. They remain warm because of the gravitational forces between Enceladus and other Saturn's moons. Water is the key element for the development of life, so you never know. Also, scientists have discovered the presence of phosphorus on Enceladus, which is another essential element for life to appear. It's one of the 6 basic building blocks of life: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. And it plays a very important role in many biological processes, e.g. cell membrane formation, energy transfer. They believe the phosphorus probably comes from the moon's rocky core and is transported to the ocean through hydrothermal vents. Moving to the next potential location that could contain some form of life: Titan, Enceladus's big brother. It's the only moon in our solar system that has clouds and a dense atmosphere you'd normally find on planets. And it's the only known place in our solar system, except for Earth of course, that has liquid lakes filled with methane and ethane, liquid natural gas. But still, Titan is a world that resembles Earth the most. Scientists even believe that conditions there are similar to those Earth had in its early years. Our home planet is closer to the sun though, so it's always been warmer. Titan might also have an underground ocean of liquid water beneath its surface. We can't miss Mars when we're talking about the possibilities of life in space. One of the main pieces of evidence is methane scientists found on the red planet. Methane is a gas that can be produced by living organisms, think cows, so it might be an important sign. They have also found organic compounds on the surface of Mars, which are the building blocks of life. Another promising discovery on Mars is liquid water. There could be a lake located under a polar ice cap, and scientists believe it could even contain microbial life. Europa is one of the moons that orbit Jupiter. It potentially has plenty of water too. There could be a salty ocean under its nearly 10 miles thick crust, with more water than all of Earth's oceans contained together. There's likely a rocky seafloor at the bottom of this mysterious ocean. The interaction between the rocks and the ocean could create chemical nutrients that organisms, if there are any, need to survive. Europa's secret ocean probably has hydrothermal vents too. Those are basically areas where hot water and minerals are released from the seafloor. These vents support a variety of life forms on Earth, so it's exciting to know that there's a possibility that similar life forms could exist on Europa as well. The problem could be radiation coming from Jupiter. It's really strong, and as such, it can be really harmful to any potential life forms there. Any life on Europa would need to have some sort of shield, so it could survive such intense radiation. Let's also check the second biggest Jupiter's moon, Callisto. It has many craters, but it's still one of the most geologically inactive bodies in the solar system, with no active volcanoes or tectonic activity. That's why its surface is mostly the same as it was at the time the moon formed, which is why it gives us a unique window into the early history of the solar system. And you guessed it right, Callisto also has a subsurface ocean that could potentially hold life. Fun to think about, eh? Imagine a black hole, a terrifyingly dense space object, pulling inside everything that comes too close. Nothing can escape its clutches, even a beam of light. And now imagine two of these space monsters colliding. Scary? You bet! Astronomers have spotted two supermassive black holes feasting on the cosmic material of two merging galaxies in distant space. This phenomenon is the closest to colliding black holes we have ever seen. Supermassive black holes are the largest among all black holes out there. Their mass can be hundreds of thousands or even millions to billions of times larger than of our suns. And two such giants have been recently spotted with the help of an array of telescopes in northern Chile's Atacama Desert, the Atacama Large Millimeter Submillimeter Array of Telescopes, ALMA. Astronomers originally used these telescopes to watch two merging galaxies located approximately 500 million light-years away from Earth. Thanks to being alert at all times, scientists have also noticed that two gigantic black holes were growing alongside each other. Apparently, these black holes came across each other when their host galaxies collided. One of the black holes is around 200 million times the mass of our Sun, and the other is a bit smaller, only 125 million times larger. We can't see black holes directly. If you were to travel to a black hole, you wouldn't notice it until it was too late. The only detail that would give away the approaching black hole would be a slight blurring of distant stars due to the hole's gravitational lensing effect. The two black holes we are talking about are no different. They aren't visible directly, but are surrounded by bright clusters of warm, glowing gas and stars. All of this has been tugged close by the black hole's gravitational pull. Time will pass, and these black holes will start circling each other, and eventually they will collide, creating one, probably even bigger black hole. Scientists have been observing these black holes across multiple wavelengths of light, and have come to the conclusion that they are unique. They're located the closest to each other astronomers have ever seen. The distance between them is a mere 750 light-years, which, astronomically speaking, is just next door. Even more exciting, this distance is close to the limit of what modern technologies can detect. The thing is, such ginormous merges are more typical for distant galaxies. This makes it harder for Earth-based telescopes to see them. But the sensitivity of ALMA, Atacama Large Millimeter Submillimeter Array of Telescopes, helped astronomers observe those bright and compact regions where matter swirls around the black holes. Imagine how surprised astronomers were when, instead of one black hole, they discovered two of them, munching on the dust and gas stirred up by the massive space merger. Galaxy mergers are way more common in the distant universe than in our neighborhood, and this discovery may mean that such black hole binaries are likely to be much more common than we previously thought too. And if pairs of black holes are so common, it might make it easier for us to study gravitational waves. These waves, also known as ripples in space-time, occur when black holes collide. If we talk about the recently discovered pair of black holes, it might still take them several 100 million years to crash into each other. But by observing their behavior, scientists can figure out how many binary black holes there are that are about to collide in the universe. Also, this may give us more insight into what is going to happen when our home Milky Way galaxy collides with the Andromeda galaxy in around 4.5 billion years. By the way, the first photo of a black hole was taken in 2019. An international team of scientists consisting of more than 200 astronomers had been working for years to get this result. And their efforts finally paid off. The object in the photo is about 55 light-years away from Earth, at the center of the galaxy M87. You can now admire this amazing space phenomenon thanks to the work of a vast global network of telescopes called the Event Horizon Telescope Collaboration, or simply EHT. The event horizon is a point of no return on the outskirts of a black hole. Once something, for example, matter, radiation, or light, reaches this boundary, there is no way for it to escape. To capture the very first image of a black hole, scientists created a virtual telescope that turned out as big as our planet by combining the power of 8 radio telescopes. But it wasn't an easy feat. The researchers had to simultaneously point the telescopes in a meticulously planned order with the help of precise atomic clocks set on each telescope. Plus, they were constantly monitoring the amount of moisture in the air, since too much humidity would ruin the images. To keep the chances of rain to a minimum, they even constructed the telescopes in super dry regions, such as the Atacama Desert in Chile and the South Pole. All in all, the process resembled a carefully coordinated dance. But thanks to these preparations, in over 2 weeks, the telescopes collected 5,000 trillion bytes of data. It was then processed by several supercomputers, and scientists finally got the long-awaited images. And what they observed was a monster of a black hole measuring about 25 billion miles across. Now, how about we talk about the coolest black hole facts? There are baby black holes called primordial, and they are really tiny. They vary from the size of an atom to that of a mountain. There is a theory that galaxies get formed around black holes. This means that when a large star explodes, a black hole appears in its place, and then the rest of the galaxy just forms around it. There is a supermassive black hole right in the middle of the Milky Way galaxy. Its name is Sagittarius A, pronounced A star, and it's 4 million times as heavy as the Sun. And nope, we aren't going to be pulled into this hole. It's more than 26,000 light-years away from Earth. That's too far for this monster to have any influence on our planet. Besides Sagittarius A, there are 100 million medium-sized black holes in our galaxy. And can you imagine how many black holes in total there are in all 100 billion galaxies that exist out there? You do the math. If you ever find yourself near a black hole, be ready that time will slow down significantly. It may work for you if you aren't so eager to grow older. Just don't let yourself be tugged into the event horizon. Whoops, bye-bye. Black holes aren't some hungry predators that roam the universe preying on poor, unsuspecting planets. They just gulp down the stuff that ends up too close to them. On top of that, they sometimes fling out spitballs the size of a planet. How does this matter escape the pull of black holes? Typically, it manages to slip away before going past the point of no return. In fact, with Sagittarius A, we should be worried not about its gravitational pull, but about the very spitballs. After all, the monster black hole hurls them in the direction of Earth at a speed of 20 million miles per hour. What if, one day, one of them reaches our planet? If you manage to squeeze Earth to the size of a cherry tomato, it would turn into a black hole. In fact, you could also become one if you agreed to be scaled down to an atom. South African astronomers have recently come across another head-scratching black hole mystery. In a region of distant space, they noticed that several black holes located in different galaxies aligned in the same direction. It looks as if their gas emissions have been synchronized by design. Nowadays, scientists can't explain why and how black holes, which are about 300 million light-years away from one another, can be acting in unison. It's a puzzlement. An object weighing billions of times the mass of our sun must be easy to find, right? Wrong. Unfortunately, it might not be that simple, like in the case with a missing black hole. But let's travel to the galaxy cluster Able 2261, hosting a supermassive black hole at its center. Or at least, that's where it's supposed to be. The main problem is this giant space phenomenon is nowhere to be found. Now, supermassive black holes are mega monsters, churning slowly at the centers of their home galaxies. They gather tremendous clouds of gas and dust around them, which makes them swell up to sizes the human mind can't begin to imagine. If a supermassive black hole, like the one that dwells at the center of our home Milky Way galaxy, moved even a bit closer to our solar system, we'd be doomed. The distance between this huge thing and Earth could be several dozens of light years, and still, it would wreak havoc on our planet. Earth, along with other things making up the solar system, would be tugged into the black hole's orbit and doomed to spin around it for eternity or longer. Hey, who knows, right? So it's good that such black holes stay away from us at the moment. So, let's see what's happened with that runaway supermassive black hole from that gigantic cluster of galaxies around 2.7 billion years away from our planet. Scientists have been looking for it with the help of NASA's Chandra X-ray Observatory and Hubble Space Telescope, but so far, no result. The main problem with finding a black hole is that it's, black, and space is, you guessed it, black too. So there's no contrast whatsoever that could help astronomers spot the hole, but scientists haven't given up yet. After all, they have a lot of other technologies to find black holes, small and big, in the vastness of space. Some of these methods involve watching the stars orbiting black holes. Sometimes it's a faint gravitational wave signal, which is produced when two black holes collide, but the most reliable technique is watching dust and gas falling to their doom. The thing is, black holes are space objects with insane gravity, so regions of space surrounding them are usually a bit chaotic, gas and dust getting pulled into the bottomless abyss, compressing and heating up. In the process, it releases a flood of X-ray radiation, so astronomers look for extremely bright X-ray sources in the universe. Chances are, those are the last gasps of giant clumps of material before they disappear into a black hole. Then why can't scientists find such X-ray signatures left by the black hole in Able 2261? One of the most mysterious things about its disappearance is that radio telescopes have spotted some signs of massive plumes of superheated material, launched at one point within the last 50 million years. These plumes were most likely caused by a large black hole, which is nowhere to be found these days. So, at the moment, we can only play a guessing game. Maybe two medium-sized black holes collided, pushing the newly merged giant out of the center of the galaxy. The observations of the stars in that galaxy have shown a clump of dense material a few thousand light-years away from the galaxy's core. Maybe it's the runaway black hole, but disappointingly, no X-ray signals are coming from that clump. Or the hole might still be there, in its rightful place, but it's, slumbering. If it doesn't get a fresh supply of gas and dust, it has nothing to feed on. As a result, it can't release a flood of X-rays. But again, the answer, do not disturb, the black hole is sleeping now, isn't very satisfying. Why isn't it getting its space food? What happened 50 million years ago? What is that clump of material speeding away from the galaxy center? So many questions and no answers so far. At least we know what black holes look like. Well, kinda. It's actually the shadow of a black hole's event horizon visible against the glowing superheated material falling inside the hole. The first ever mugshot of a black hole appeared in 2019, but the data for its creation was collected in 2017. It took an international team consisting of more than 200 astronomers 2 years to assemble the image. We can admire this amazing space phenomenon thanks to a vast global network of telescopes called the Event Horizon Telescope Collaboration, or simply EHT. Why such a name? The thing is that the event horizon is a point of no return on the outskirts of a black hole. Once something, for example, matter, radiation, or light, reaches this boundary, there is no way for it to escape the black hole's clutches. Anyway, to capture the very first image of a black hole, scientists created a virtual telescope that turned out as big as our planet by combining the power of 8 powerful radio telescopes. But it wasn't an easy feat. The researchers had to simultaneously point the telescopes in a meticulously planned order with the help of precise atomic clocks set on each telescope. Plus, to keep the chances of rain and bad weather to a minimum, they even constructed the telescopes in super dry regions, such as the Atacama Desert in Chile and the South Pole. On each observation day, the telescope gathers roughly 350 terabytes of data. That's 10 times the amount of data collected every day at the Large Hadron Collider. But let's speak more about black holes themselves. There are stellar black holes, smaller but even more dangerous than their supermassive peers. They appear when stars that have run out of their star food fall into themselves. If a star used to be big enough, it keeps compressing and compressing some more, and voila, a baby stellar black hole is born. But even if I call such a hole a small one, it's still 5 to several tens of times heavier than the sun. Unlike their massive siblings, hypothetical mini black holes could be really tiny, not bigger than an atom. Even so, just one minuscule thing would have the mass of 1,000 SUVs. One theory claims tons of micro black holes could have been created right after the Big Bang and the beginning of the universe. Some scientists even go as far as to say that a couple of mini black holes pass through our planet every day. There is a supermassive black hole smack dab in the middle of our galaxy, the Milky Way. Its name is Sagittarius A, and it's 4.3 million times as heavy as the Sun. And nope, we aren't going to be pulled into this hole. It's more than 26,000 light years away from Earth, too far to have any influence on our planet. By the way, recently, astronomers have discovered that this supermassive black hole might be leaking. If it's true, it probably means that Sagittarius A isn't a sleeping giant. As previously thought, it might still be active, and the leakage recorded by scientists may be the hole hiccuping while swallowing clouds of gas. Maybe we should burp this baby? If you ever find yourself near a black hole, get ready that the time will significantly slow down. It may work for you if you aren't eager to grow older. Just don't let yourself be tugged behind the point of no return. Another danger of hanging around a black hole is that it might start behaving like a massive galactic volcano. From time to time, black holes flare up, but instead of spewing lava, they produce enormous amounts of energy, and it makes gaping holes in the surrounding material and gas. A short while ago, scientists discovered one of the largest craters in the universe. Radio and X-ray telescopes detected a supermassive black hole that threw a temper tantrum many years ago. It happened in a galaxy cluster about 390 million light years away from Earth. The crater left behind, which was actually a hole punched in the cluster's hot gas, could fit 15 Milky Way galaxies. Okay, mind blown. I'm out of here. Let's see, there's Mercury, Venus, Earth, Mars, Phaeton, Jupiter. Hold on, what? What Phaeton am I talking about? Well, let's see. It was the beginning of the 19th century, and the asteroid belt hadn't been discovered yet. In the year 1801, one man called Giuseppe Piazzi spotted the largest asteroid in the solar system, Ceres. At that time, people believed that there was a planet orbiting between Mars and Jupiter, and Ceres seemed to fit the bill. But the next year, another astronomer, Heinrich Olbers, found one more space body following a similar orbit. It was an asteroid which was later called Pallas. This discovery helped Olbers to figure out that these two space objects could be fragments of a planet. The discovery of two more asteroids, Vesta and Juno, seemed to confirm this theory. It was believed that the planet, which was named Phaeton in the 20th century, appeared in the early days of the solar system and was later destroyed, and its debris formed the asteroid belt. Olbers' idea was called the disruption theory. To astronomers of that time, it seemed obvious that the planet once collided with a large space object, which led to its demise. The most likely candidate was Nemesis, a hypothetical red or brown dwarf orbiting our sun. Another theory claimed that Phaeton could have gone through an internal cataclysm, which could have broken the planet into pieces. There was one more idea. Phaeton could have come too close to Jupiter and got torn apart by the gas giant's immense gravity. These days, though, astronomers don't believe in the disruption theory anymore. A new idea has replaced it. It's known as the accretion theory. It claims that the asteroid belt is all that is left of the protoplanetary disk. Supposedly, this disk had been originally orbiting the sun, even before the planets formed. Unfortunately, because of Jupiter's gravitational forces, it never managed to coalesce into a planet. But what is this asteroid belt we keep talking about? This region is located between the orbits of Jupiter and Mars. Tons of asteroids and even minor planets are found there. Some of them can sometimes migrate or get thrown out of the asteroid belt to the outer solar system. The four largest asteroids in that area are Ceres, Vesta, Pallas, and Hygeia. They make up half the mass of the entire belt. As for the rest of the mass, countless smaller bodies make up for it. In loads of sci-fi movies about space, the main character gets into an asteroid belt and has to try hard to get away from countless rocks, threatening to smash their spacecraft. Well, it has nothing to do with the real thing. Even though there are thousands of asteroids in this region, they're so widely spaced that the chance of collision is next to nothing. Hey, but it's a movie, right? Anyway, when the asteroid belt was forming, some objects started to come together and form what we know as protoplanets. But the gravitational pull that was caused by the formation of Jupiter made such collisions too rough, and instead of forming large space bodies, like planets, asteroids shuddered. Astronomers think that as a result of such collisions, more than 99.99% of the original mass of the asteroid belt was lost in the first 100 million years of the history of the solar system. Only the largest asteroids have enough gravity to get a spherical shape. Smaller ones are often just piles of rubble loosely held together by gravity, and the tiniest objects in the asteroid belt resemble dust, so small they are, and all these objects, giant and tiny, orbit the sun. There are several types of asteroids depending on their composition and albedo, which is the proportion of light or radiation reflected by a surface. The main types are carbon asteroids, which have a very dark surface. Silicon ones, you can also call them stone asteroids. And metal ones. The first two types account for around 75% and 17% of asteroids we know about. For the first time, the asteroid belt was crossed by a spacecraft in 1972. It was the Pioneer 10 space probe. The spaceship managed to refute the theory that the belt was filled with dust that could easily damage all gadgets on board. It didn't happen, and since that time, 8 more probes have traveled through the asteroid belt. And now, I'm about to tell you some cool facts about the solar system itself. Try to count how many of these facts you've known before, and write your answer down in the comments below. The solar system is a staggering 4.5 billion years old. Scientists came to this conclusion after studying meteorites, the oldest material they managed to find. But our solar system isn't the only one in the Milky Way galaxy. The galaxy we live in houses about 100 billion star systems, and if it's just our galaxy alone, what can we say about the whole universe? Our sun is also insanely massive. Here's some proof. 99.86% of all the mass of the solar system is the mass of the sun, in particular, hydrogen and helium it's made of. The remaining 0.114% is mostly the mass of the solar system's 8 planets. By the way, contrary to popular misconception, outer space isn't a perfect vacuum. It contains not only stars and planets, but also clouds of interstellar dust, space plasma, and cosmic rays. Those are atom fragments dashing from the outskirts of the solar system. One phenomenon astronauts should worry about while exploring space is cold welding. If two pieces of the same kind of metal touch in space, they bond and get permanently stuck together. Kinda like galaxy glue. It doesn't happen on Earth since water and air keep pieces separate. You can see solar eclipses because even though the moon is 400 times smaller than the sun, it's also 400 times closer to Earth, so it's perfectly capable of obscuring the star. But in 600 million years, the moon won't be able to block the sun completely because of the satellite's changing orbit. Behind the orbit of Neptune, there is the mysterious Kuiper Belt, filled with massive icy objects. The most curious thing about this space formation, though, is that scientists fail to explain the pattern of its movement. The only explanation they have is that Neptune might be hiding a ginormous planet. This hypothetical planet has already got the name Planet 9, and all we have to do is wait until its existence is confirmed. Or not. The ocean on Jupiter is larger than any body of water on other planets of the solar system. But it's not the ocean you think about. The one on Jupiter isn't made of water. This mesmerizing thing consists of metallic hydrogen, and its depth is around 40,000 kilometers, which is actually almost the same as the circumference of Earth. People got to know about beautiful Saturn's rings in the 1600s. But now we know that Saturn isn't the only ringed planet. All the giant gas planets, Uranus, Neptune, and Jupiter have rings of their own, but they are thin and almost impossible to see. As for Mars, Venus, and Earth, they are made of rocky materials and have no rings. At the same time, Saturn's moon Rhea might have a ring system consisting of 3 narrow bands. If astronomers manage to confirm it, it'll be the first time for people to discover rings around a moon. Oh, and Mars might get a set of rings of its own in the next 70 million years. The red planet's largest moon, called Phobos, is orbiting closer and closer to the planet. One day, it's likely to get broken apart by the gravitational pull of the red planet and turn into a ring that can last for millions of years. And another cool fact about Mars. You've probably heard of methane gas, a byproduct of such natural processes as volcanic activity and cow emissions. Anyway, this gas is not only a part of the Martian atmosphere, but also the thing that confuses astronomers to no end. The thing is that the volume of methane on Mars keeps wavering, and scientists just can't figure out where it might be coming from. Can there be life on Mars? Can there be cows on Mars? Solar eclipses are cosmic magic tricks during which the moon suddenly swallows the sun. Only they work, not on magic, but on simple science. Let's try to find out how exactly they work, and how you personally can observe this fascinating event. It all starts when the moon, the sun, and the Earth line up in a straight line, with the moon positioned directly between us and our favorite star. This alignment is possible because the moon's orbit around the Earth is slightly tilted relative to the Earth's orbit around the sun. Solar eclipses only happen during new moons, when the moon is closest to the Earth in its orbit. So, when the alignment is just right, the moon's shadow is cast on the Earth. blocking the sunlight from reaching us. Imagine being in a room with a giant light switch, but instead of turning the light off, you just cover it with a big ol' moon. That's basically the solar eclipse. Solar eclipses aren't a regular occurrence, and they only happen a few times each year. The frequency of solar eclipses is determined by many things, like the alignment of the moon, sun, and Earth, and by the position of the moon in its orbit around the Earth. There are three main types of solar eclipses: total, partial, and annular. A total solar eclipse occurs when the moon completely covers the sun's disk, and the sky becomes dark as if it were nighttime. This phase can last for a few minutes to just over an hour, depending on the distance between the moon and the Earth at the time of the eclipse. A total solar eclipse can only be visible from a specific region on the Earth called the path of totality. This path is typically a narrow strip of land or sea, and if you happen to be exactly in the right spot, you'll be able to enjoy this wonderful view. Unfortunately, not everyone is so lucky to get to see a total solar eclipse. Sometimes the moon only covers part of the sun. In that case, you'll see a crescent-shaped sun instead of a completely swallowed one. That's called a partial solar eclipse. And if you're really unlucky, the moon might be too far away from the Earth to completely cover the sun. In that case, you'll see a bright ring of sunlight around the moon's silhouette. That's called an annular solar eclipse. Solar eclipses are some of the most spectacular celestial events that we can observe from Earth. People have observed and studied them throughout history, and they've played a significant role in our understanding of the sun, moon, and Earth. For example, we use them to measure the size and distance of the moon and the sun, to study the solar atmosphere, and to test Einstein's theory of general relativity. Solar eclipses have always been important to people, so it's not surprising that they've always been connected to different myths and superstitions. Some cultures saw them as a sign of dreadful things to come, or a way to talk to their deities. Others thought they could be used to predict the future, or scare away evil spirits. All these beliefs show how much solar eclipses have meant to people. There have been many fascinating and memorable solar eclipses throughout history, each with its own unique story or significance. Here are a few examples of some of the most mysterious, cool, or famous solar eclipses. The eclipse of Thales is one of the most famous solar eclipses in history. It's said to have occurred in the year 585 BCE, and it was reportedly predicted by the ancient Greek philosopher Thales of Miletus. According to legend, Thales was able to predict the eclipse by observing the cycles of the moon, and his prediction is said to have amazed and frightened the people of the time. The eclipse of Ptolemy was a total solar eclipse that's said to have occurred in the year 150 CE. It's famous because it's mentioned in the writings of the ancient Greek astronomer Ptolemy. He used his observations of the moon's cycles to make his prediction, which astonished and alarmed the people of that time. The eclipse of the century was a total solar eclipse that occurred on July 11, 1991. It was visible across a substantial portion of South America. It was the longest total solar eclipse of the 20th century, lasting for more than 6.5 minutes. The eclipse of the pyramids was a total solar eclipse that occurred on March 20, 2015, and it was visible from parts of Europe, Africa, and the Middle East. It got famous because it passed directly over the ancient pyramids of Giza in Egypt, providing a unique opportunity for scientists and tourists to study the eclipse from this historic location. And, of course, the Great American Eclipse of 2017. It was a total solar eclipse that was visible across a large portion of the United States, from coast to coast. It was the first total eclipse visible from the contiguous US in nearly 40 years, and it attracted millions of spectators and was widely covered by the media. Since they happen quite rarely, you wouldn't want to miss such an event. Fortunately, we have a calendar of solar eclipses that will occur in the next few years. The Great North American Eclipse of 2023, expected to be visible in a substantial portion of North America, from the Pacific Northwest to the Great Lakes region. It will be the first total eclipse visible from the United States since the Great American Eclipse of 2017, the Eclipse of the Andes of 2024. This one is expected to be visible across parts of South America, including parts of Chile and Argentina. It will be the first total eclipse visible from South America since the Eclipse of the Century in 1991, the Eclipse of the Arctic of 2025. This one will be visible in the Arctic part of our planet, including parts of Canada and Greenland. It will be the first total eclipse visible from the Arctic in nearly 100 years, and the Eclipse of the Pacific of 2026. This eclipse will be visible across parts of the Pacific Ocean, including parts of Australia, New Zealand, and the United States. It's worth noting that the exact timing and visibility of these solar eclipses may change as more precise predictions are made. Also, some other solar eclipses may also occur in the coming years. Don't forget to check the details online. But the most important question is, how do we watch them? The answer: very carefully. Here are some general tips. Use proper eye protection. Never look directly at the sun, even during an eclipse. It's not worth risking your sight. To observe a solar eclipse safely, use things like certified solar eclipse glasses or a pinhole projector. These devices allow you to view the eclipse without looking directly at the sun, and they help to protect your eyes from the harmful effects of the sun's rays. Find a good viewing location. To get the best view of a solar eclipse, it's important to find a location that is within the path of the eclipse and has a clear view of the sky. Use a camera or telescope. If you have a camera or telescope with a solar filter, you can use it to take pictures or observe the eclipse more closely. Just be sure to use a solar filter to protect your eyes and equipment. Stay informed. It's important to be up to date about the details of a solar eclipse, including the exact timing, location, and type of eclipse. This information can help you plan your viewing and ensure that you have the proper equipment and safety precautions in place. That's it. Simple, isn't it? By following these tips, you can enjoy observing solar eclipses safely and responsibly. And if you do get to see a solar eclipse, make sure to snap some pics and share them with your friends. Remember, it's a once-in-a-lifetime experience, after all. Ever wondered what it would be like to hear the sound of a black hole? NASA has got you covered. Here is a screaming black hole. Screaming. In space? I thought in space, no one can hear you scream. Well, let me explain. Using a telescope, NASA examined the movements of hot gas in a cluster of galaxies in 2002. Then they converted what they found into a sonification. The sound, how should I put it politely, wasn't appealing, but that's okay. After all, you're able to hear the noise hot gas produces in a cluster of galaxies 250 million light-years away. Hey, would you like to hear the sound gas produces right here on Earth? Never mind. Sound waves already existed over there in the gas cluster, so experts just rescaled them to the range of human hearing. This is how they converted the input coming from the telescope. The principle is universal. In our atmosphere, we can hear stuff because pressure waves move through a medium like liquid or gas. Sound waves in these galaxies can also move because they're surrounded by gas. What does it have to do with black holes? Well, the thing triggering those pressure waves in the cluster is a giant black hole. To be more precise, it's a supermassive black hole that weighs millions of times more than the sun. Experts still don't fully understand the relationship between supermassive black holes and the clusters surrounding them. They only know that these two evolve together. They're interrelated. The cluster feeds the black hole with new material and so on. And in return, the black hole heats the cluster. That's all we know. Now, this made me wonder how large the biggest black holes are. There are 4 types of black holes: stellar, intermediate, supermassive, and miniature. Naturally, the biggest ones fall into the category of supermassive. The largest black hole in the universe we've discovered so far is about 66 billion times larger than the sun. It's one of the brightest objects in the universe. Astronomers keep scanning space and finding new black holes. But have you wondered when the first black hole was spotted? It was discovered by different researchers independently in 1971. Scientists first confirmed that these objects were formed from the remnants of massive stars. After a black hole appeared, it then consumed all the nearby objects. Here is a quick recap of how these space objects work. Their gravitational force is super strong. Nothing can escape a black hole after crossing the event horizon. Black holes eat everything, just like me. I mean, even light gets trapped inside them. What's even cooler, scarier, is that the laws of time and space become distorted there. If you were falling into a black hole, you would realize that time slows down there. Einstein explains this in his famous general relativity theory. In very, very basic terms, time gets affected by how fast you are moving at extreme speeds. NASA has discovered a rapidly growing black hole, but don't worry, the world isn't in danger. This black hole has been in front of the eyes of astronomers this whole time. It's in a region of a well-studied sky field. Astronomers say that this hole formed 750 million years after the Big Bang. You know, the birth of our universe. So why are black holes so bright? Well, that's a bit ironic. When I defined this space phenomenon, I said that black holes were so dense that even light got trapped there. But ask any astrophysicist, and they'll confirm that black holes are among the brightest objects in space. That's because black holes don't exist alone. They sit at the centers of galaxies and are usually surrounded by clouds of hot gas. And these clouds create cosmic auras around black holes. I must mention though, that you can't see a black hole directly. What you see is actually the effects it has on its environment. For instance, you can see space objects being ripped apart by a black hole. Remember when the first time ever silhouette image of a black hole was shared with the public in 2019? Proof, you fellas. You wouldn't really see the black hole if there was no orange ring. Why is the ring orange and not green or purple? The dark circle inside is the shadow of the black hole. The glowing orange of the bright ring in the image isn't the real hue of the gas. I'm a little heartbroken here. It's a representation picked by researchers to depict the brightness of the emissions. A scientist explained that yellow is the most intense emission, red is less intense, and black has little or no emission at all. In the optical range, this ring would likely seem white, perhaps tinged with blue or red. Spaghettification is a real word. That's an astonishing ability black holes have. If a giraffe fell into a black hole, it would stretch into a long, spaghetti-like strand. On Earth, the giraffe's legs are closer to the center of Earth, so they're more powerfully attracted to the surface than the animal's head. This rule works in the animal's favor on Earth, but would work against it inside a black hole. In a black hole, there's extreme gravity. The closer the giraffe's legs got to the center of the black hole, the more the pull of gravity would stretch them, and the closer to the center the giraffe got, the faster its legs would move. But the top half of the giraffe's body would be farther away, so it wouldn't move toward the center as fast as the legs. Here comes the spaghettification. Can we have meatballs with that? No? The only difference between a black hole and our sun is that the center of the hole is made of super dense material. It provides the black hole with a strong gravitational field that can trap everything, including light. This is why we can't see black holes. Did you know that theoretically, you could turn anything into a black hole? For instance, if you shrank the sun to approximately 4 miles across, you would compress the matter inside to an extremely small size. This would make it so dense that our star would turn into a black hole. You could do the same with a planet or even your own body. Is there something called a white hole? Or is it just a myth? White holes exist in theory. Hypothetically, they function in the opposite way to black holes. Nothing can enter them. Physicists think of black and white holes as yin and yang, or two sides of the same coin. For them, a white hole looks exactly like a black hole, which makes different things come out of it. But the existence of white holes hasn't been proved yet. And how about wormholes? There are so many movies about black holes and wormholes. How many of them are based on reality? And how much is fiction? Some people believe that black holes function like wormholes. You go inside and exit in another part of the universe. Since we still have a lot to learn and discover about physics, no one can prove this theory is wrong or right. Astrophysics says we need to have a solid theory that unifies general relativity with quantum mechanics. Black holes are among the largest structures in the universe, but there might be tiny specimens. The mass of the smallest black hole we know about is only 3 times greater than that of our Sun. Apparently, black holes can vanish. Stephen Hawking developed a theory of Hawking radiation. According to it, radiation decreases the mass and rotational energy of black holes, and ultimately, they evaporate. This process occurs very slowly, though, if we're not talking about small black holes. Astronomers have discovered an elusive black hole in the neighboring galaxy. What makes this one special is the fact that it's the first dormant stellar black hole outside of our galaxy. This type of black hole is hard to observe because such holes don't interact much with their environment. They don't emit as much radiation as other black holes. Back here on Earth, what about sinkholes? Well, different physics. Yet, if you cross the event horizon, your whole car can disappear. Whoops. The Hubble Space Telescope was put into a low Earth orbit in 1990. If you think about it, it has had over 30 years of experience looking at various space objects. It was named after astronomer Edwin Hubble and was built by NASA. It is also part of a group of devices called NASA's Great Observatories, along with the Compton Gamma Ray Observatory, the Chandra X-ray Observatory, and the Spitzer Space Telescope. The Hubble Space Telescope was built to explore the universe and answer some of its biggest questions, such as how galaxies form and evolve, and how the universe itself has changed over time. The telescope has made many important discoveries, including providing evidence of the existence of dark matter and helping to determine the rate of expansion of the universe. One of the most famous images taken by the Hubble Space Telescope is the Pillars of Creation. It's a photo of a region of the Eagle Nebula where new stars are born. The photo, which was taken in 1995, shows massive pillars of gas and dust towering above the nebula. It has become one of the most iconic images of the universe. The Hubble Space Telescope continues to operate and make important scientific discoveries, despite some initial technical difficulties. In 1993, a problem in the telescope's main mirror was discovered, which affected its ability to focus light properly. A repair mission was sent to the telescope in 1994 to fix the problem. And since then, the telescope has continued to work perfectly. One of the most interesting discoveries made by this amazing telescope is actually pretty recent. A report based on the data from the Hubble Space Telescope shows that there is a faint glow in space around the solar system that cannot be explained by anything we know to exist. Because they have yet to figure out the source, astronomers call this mysterious glow ghost light. We do know that this light is not coming from the stars or galaxies near the solar system, nor is it coming from dust on the solar system's plane. The researchers are not sure what the source of the light is, but they think it might be tiny particles of dust and ice left by comets. But it's only a theory that has not been confirmed. When we study the universe, we often find bright things like planets, stars, and galaxies. But from time to time, we discover some light coming from places where we didn't expect to see it, like from between planets. This light may be coming from deep within our solar system, and it may be a new phenomenon that hasn't been studied before. In other words, there may be something at the center of our galaxy that produces a lot of light. Spacecraft Voyager. I also captured images showing a lot of light coming from the edge of our solar system. How come we haven't noticed this until now? Well, because most of the light in pictures taken by the Hubble telescope comes from things close to Earth. But people usually ignore this light because they're interested in things like stars and galaxies that are farther away. We've never actually looked closely at the amount of light in the universe and where it comes from. Scientists have been using the Hubble to find faint galaxies that may have been missed before and which may be the source of this dim glow. They found that there are not enough such galaxies to account for extra light in the sky. It's not a lot of light though. It is like the glow from 10 fireflies. but it doesn't make it less important. It shows that we may be missing something. Let's look at some other important discoveries we've made with the help of Hubble. Like dark matter, which we can't see but know is there because of its effect on gravity. It makes up for about 23% of the universe. By looking at how it affects light, the Hubble telescope helped make 3D maps of where dark matter is. These maps showed that dark matter seems to be getting clumpier over time, which means it behaves very similarly to how gravity does. The Hubble telescope also discovered 2 new moons around Pluto, named Nix and Hydra, and studied the dwarf planet's changing surface. Additionally, it's found the mass of planet Eris, which is larger than Pluto. This helped scientists realize there may be similar objects in the Kuiper Belt, a region outside our solar system. This led to Pluto being reclassified as a dwarf planet. Further observations of these distant objects could help us understand the evolution of our solar system. Gamma-ray bursts are the most powerful explosions in the universe, and for a long time, no one knew where they had been coming from. Hubble helped us find out that these bursts happened in galaxies producing a lot of stars and having few heavy elements. This suggests that gamma-ray bursts happen when big stars collapse into black holes. These galaxies have lots of big stars that fall apart quickly, and the stars there don't have much heavy stuff, so they can turn into black holes. In 1994, the Shoemaker-Levy 9 comet collided with Jupiter. Hubble captured the whole event in detail, like a resourceful journalist. The impact broke the comet into a lot of small pieces, which resulted in 21 other visible collisions. The largest impact created a fireball and a dark spot on Jupiter's surface. Hubble's observations not only sparked public interest in cosmic impacts, but also provided new insights into Jupiter's atmosphere. To move forward with our list of discoveries made by the Hubble telescope, we also need to talk about black holes. They are points in space where gravity has so much force that even light cannot escape it. The gravity becomes so strong that matter gets squeezed into a very small space. We know that this can happen when a star, like the Sun, nears the end of its life. At the beginning of its life, a star's hydrogen ignites in its dense, hot core. Because of gravity, it tries to draw its own mass into a tiny point. As long as it has the energy generated by the hydrogen fusion, it also pushes outward. If we look at it this way, the life of a star depends on a delicate balance between these forces, and it can last millions or even billions of years. Once that energy is exhausted, the only force remaining is that of gravity. So some stars become black holes. Since light itself cannot escape their pull, we can't visualize black holes. For the human eye, they are invisible. We need special tools and unique telescopes to help us point them out in the universe. Hubble found that most galaxies with a central bulge of stars likely have supermassive black holes. It has also noticed a strong connection between the sizes of these black holes and their host galaxies, which might help us understand how the universe has changed over time. Then what is a supermassive black hole, you might ask? Go ahead, ask it. It is a very large black hole that is typically found at the center of a galaxy. It is millions or even billions of times more massive than the Sun. These black holes are so powerful that they can swallow stars and even entire galaxies. Scientists are still exploring these mysterious objects, but they believe that they play a crucial role in the formation and evolution of galaxies. Before Hubble, we didn't really know how old the universe was. It often led to weird paradoxes, like the one where stars discovered by astronomers were older than the universe itself. But by figuring out the approximate rate at which the universe is expanding, Hubble helped us narrow down its age, about 13.75 billion years. Trying to figure out the exact age of the universe is an important question. That's because most astronomers think that the universe has not existed forever, but Let's face it, as stars go, our sun is actually, well, pretty boring. Come on, there's nothing unusual about it. There are millions of similar yellow dwarfs in the universe, and yet we love it. After all, it's the only star we have, and it gives us life. However, it wasn't always like that. Once upon a time, the sun had a twin, possibly an evil one. What happened to it? Well, let's find out. This here is a giant molecular cloud. They're also sometimes called dark nebulae. Here, there are many interstellar clumps full of gas, dust, and piles of stars. These clouds have no clear boundaries and often take weird, crazy forms. You can even see some of them with the naked eye. Look at the clear sky at night. They look like dark spots all across the bright Milky Way. And this is exactly where our sun was born about 4.5 billion years ago. The sun originated from one of these molecular clouds. Billions of years ago, waves of energy were passing by here. They collected all this material and compressed these clumps into dense nuclei. That's when a protostar was born. This young protostar was a ball of lukewarm hydrogen and helium. And then, millions of years later, the temperature and pressure inside the balls increased. As a result, a star was born. The sun. But not everything in this molecular cloud has turned into the sun. The remaining materials began to revolve around the new star, and as you might have guessed, they gradually turned into planets, including our Earth. This is how our solar system was created, but it's quite possible that this is not the whole story, and that at the same time, along with our star, another one was born. The lost twin of the sun, made from the same materials under the same conditions. But why do we think that it exists? Recently, scientists have launched some statistical models to find out more about the birth of stars. And these models have shown that many stars appear not individually, but in clusters, or with at least one sibling. After more research, scientists confirmed that, yep, most stars formed inside molecular clouds are born with a companion. Sometimes these companions stay together. For example, a small star will revolve around a large one. They can even form double, triple, and other star systems. And sometimes, their paths may diverge forever. This probably happened to our sun as well. It could have had a sibling, perhaps not even one, but a whole cluster of little brothers and sisters, in one bigger twin with a similar mass and other characteristics. But if that's the case, then where are you, our lost twin? Well, we have one hypothesis, and according to it, this twin may not be as good as it seems. In the 1980s, scientists began to notice a certain pattern in the Earth's history. Approximately every 27 million years, give or take, large-scale extinctions occurred on our planet. Pretty strange, right? Every 27 million years in the history of Earth, some kind of catastrophe occurred that changed its biosphere forever, as if something, as scheduled, cyclically, caused them. Then an astronomer, Richard Muller, suggested that there may be something that caused these events, a certain celestial body. According to him, it could be a dwarf star that we can't see because of how dim it is. It could be located about 1.5 light years away from us. This star rotates around the sun in a huge orbit, and it approximately takes a whopping 27 million years for it to finish its orbit. And when it gets the closest to the sun, it starts to cause complete chaos. While approaching us, this troublemaker changes the trajectories of comets in the Oort cloud, or the Kuiper belt. As a result, all these comets start to rush straight toward us. Then they crash into the Earth and cause mass extinctions, just like it was with dinosaurs. This hypothetical star was named Nemesis. It's the name of the ancient Greek deity of retribution. What is it taking revenge on us for? No idea. Perhaps it didn't like the fact that once upon a time, the sun took away almost all the dust and gas from a molecular cloud. The sun became a fairly large star, but the twin remained dark and small. Moreover, in the end, it was forced to fly away in the middle of nowhere. Anyone would be annoyed by something like this. Scientists have put forward various hypotheses about what the mysterious Nemesis is. Perhaps it's a brown or red dwarf, the remnants of a star that has completely depleted its fuel. Or maybe it's not a star at all, but a rogue planet more gigantic than Jupiter. Whatever it is, its existence isn't particularly pleasant for us. However, all our attempts to find the culprit, unfortunately, failed. At the moment, we still haven't found any signs of Nemesis. Recent studies have called into question the theory of regular mass extinctions. If you look more into fossil records, you'll notice that these catastrophes occurred rather randomly, rather than on a clear schedule. Now scientists doubt if Nemesis may actually exist. They also say that any star moving in a similar orbit would be very unstable, and it's very unlikely that it could have survived for that long. But despite the lack of clear evidence, Nemesis has become quite famous online. Many articles and news still mention it in different contexts. They like to write off any dramatic events taking place in the world, like asteroid falls, tsunamis, and so on this mysterious star. So now all this may seem like a typical urban legend. But let's not forget about something important. Even if Nemesis itself doesn't exist, it doesn't mean that the Sun didn't have a twin. First of all, everything we talked about at the beginning is still relevant. Most stars aren't born alone. The probability that our Sun also had a sibling is still very high. Secondly, there may be evidence of the existence of this lost twin, and it's probably somewhere in the Oort cloud. This is a huge cloud in the outer limits of our solar system. It consists of a bunch of comets and other cool rocks. Now, scientists believe that this cloud stores various remnants and fragments of everything that remained after the birth of our solar system. It's like a huge museum of our past. So, in this Oort cloud, scientists have noticed something interesting. Basically, this region seems to be too heavy. What the Oort cloud actually looks like doesn't correspond to our current models of the formation of the solar system. It's too heavy because there are some remnants of something in it. So there used to be something in the solar system that we don't know about yet. But when scientists included a possible second sun in their calculations, it fit just right. Like a missing piece of a puzzle, the lost twin perfectly matches the gap in the weight of the Oort cloud. So yeah, the Sun almost certainly had a twin. But what happened to it? And where is it now? Unfortunately, this star is most likely already very far away. Probably after their birth, the Sun and daughter, Sun 2.0, spent only a couple of million years together, and then they had to separate completely. Now this second twin may be hundreds of light years away from us. It can be anywhere in the Milky Way. And yeah, theoretically, we could find it, but that would be quite difficult. To do this, we need to find all the stars similar to our Sun, about the same age, all over the Milky Way. And even if we make a list of these stars, what's next? We have no way of knowing which one was really the twin of the Sun. So the lost twin will most likely remain lost, and our Sun will remain forever lonely. What a sad story. But cheer up. For us, it's probably for the best. If we had two suns, perhaps the solar system would never have become what it is now. Our planet might not exist at all, and that means that there might be no life. So we probably should be grateful for sun sacrifice. On the other hand, our sunsets would look like the ones they have on Tatooine. Cool. Attention! Attention! Something very exciting is going on Saturn. It's called a spoke season. And no, the planet isn't turning into a giant gaseous wheel. Let me tell you more about this phenomenon. Each year, NASA's Hubble Space Telescope devotes some of its time to observing Saturn, a gas giant, like me, the second largest planet in the solar system. And this space body always has something new to surprise us with. For example, look at one of the latest images of the gas giant. See those smudgy spokes? They mean that Saturn's spoke season is starting. Like our planet, Saturn is tilted on its axis. That's why it has 4 seasons. But since the orbit of the gas giant is much larger, each of these seasons lasts about 7 Earth years. Keep this in mind. It's important. Now, the next thing we need to talk about to understand the concept of the unique spoke season on Saturn is the equinox. On Earth, it's the moment when the sun is exactly above the equator of the planet, and day and night are of the same length. But on Saturn, it's something a bit different. An equinox occurs when Saturn's rings are titled edge-on to the sun. And even though equinoxes on Saturn happen every spring and fall, just like on our planet, they actually occur very seldom, roughly once in 15 Earth years. That's why astronomers are so excited about this event. Now look, There are two smudgy spokes in this ring. It's called Ring B, on the left of the picture. They resemble the spokes on a bicycle. The shading and shape of spokes vary. They may seem dark or light. It depends on the angle and illumination. Sometimes they might look like blobs, rather than something with a classic radial spoke shape. They also don't last long, but more and more will start to appear the closer we're to May 6, 2025. That's when the autumnal equinox on Saturn will occur. But what causes the spokes? Astronomers think it might be the gas giant's magnetic field. When a planetary magnetic field interacts with the solar wind, it creates an electrically charged environment. On Earth, this results in northern lights, also called aurora borealis. And if we speak about Saturn, the tiniest icy ring particles might get charged too, and it probably temporarily levitates these particles above the larger boulders the rings consist of. For the first time, the spokes in Saturn's rings were spotted by NASA's Voyager mission. It happened in the early 1980s. At that time, we didn't know that these spokes were a seasonal phenomenon. Voyager 2 just passed by the planet and then sped on. To figure out what these spokes were and how they functioned, astronomers needed a space telescope that could observe Saturn's rings from afar, like Hubble. The latest equinox on Saturn occurred in 2009. At that time, NASA's Cassini space probe was traveling around the gas giant. It sent many amazing images back to Earth. It quickly proved that the spokes weren't caused by gravitational interactions with Saturn or the influence of the gas giant's moons or small moonlets, which make up the planet's rings. It was the year 2005 when Cassini confirmed that the spokes were related to Saturn's magnetic field. That mission was finished in 2017. Now Hubble keeps its long-term monitoring of the changes on and around Saturn. Despite all the observations, astronomers still can't predict the beginning and duration of the spoke season. Luckily, Saturn's prominent rings are a perfect laboratory for studying this phenomenon. Because even though other gas giants in the solar system also have rings, those are not so visible, and scientists don't know whether spokes occur on those planets. But these spokes aren't the only exciting space phenomenon. Our solar system is a fascinating place. That's why. If you were standing at the Martian equator barefoot, your feet wouldn't get cold. The temperature there would feel like on a sunny spring day, but you would have to wear a hat. At the height of your head, it would be freezing cold. Venus spins backward compared to most other planets in the solar system and the sun itself. One of the explanations astronomers have come up with is a collision with some solid object. For example, an asteroid that happened in the past. Jupiter's moon Io has hundreds of volcanoes, which makes the satellite the most volcanically active object in the solar system. The moon also has a weird yellowish surface. It looks blotted and resembles a pepperoni pizza. Europa, one of Jupiter's 4 biggest moons, is covered with ice. This ice shell can be 16 to 24 kilometers thick. It also has some smooth patches. So, if you're into ice skating, you would like it there. If you lump together all the known asteroids in the solar system, their total weight would still be smaller than 10% of the mass of our moon. Scientists believe that Mercury might still have a partially molten core. It could explain why Mercury has a magnetic field, even if it's just 1% as strong as Earth's. Mercury's core takes up around 42% of the planet's volume. Mercury also has wrinkles. When its iron core was cooling, the planet's crust contracted. It made the surface of the planet uneven. These wrinkles are called lobate scarps. The biggest of these scarps can be hundreds of miles long and up to a mile high. Uranus is the only planet in the solar system to rotate on its side. The reason might be an ancient mega-powerful collision with an Earth-sized object, but so far it's just a theory. Mars might get a set of rings of its own in the next 70 million years. Its largest moon, called Phobos, is orbiting closer and closer to the planet. One day, it's likely to get broken apart by the gravitational pull of the red planet and turn into a ring that can last for millions of years. I won't be around then, so I'll just take their word for it. Scientists think that the moon's surface has more craters than Earth's because it doesn't have so much natural activity going on. Winds, rains, earthquakes, and erosion keep altering the surface of our planet, but the moon has almost no weather to change its appearance. Saturn is the most flattened planet in the solar system. It's squished at the poles, and any point on the equator is about 6,400 kilometers further from the center of the planet than the poles. The Hubble Space Telescope weighs almost as much as 2 male African elephants and is as long as a big school bus. Yeah, that's a launch I'd love to see. 2 elephants in a school bus. It's made almost 1.5 million observations since it was launched in 1990. Astronomers have used this data to write about 15,000 scientific papers. Everything on Earth and everything people can see in space with the help of telescopes is normal matter. It's made up of atoms and molecules and adds up to less than 5% of the universe. Almost 68% of the universe is dark energy, and the remaining 27% is dark matter. Does that really matter? As a matter of fact, it does. Saturn has a mysterious vortex swirling over the planet's south pole. The whole thing resembles an enormous hurricane-like storm, measuring almost 8,000 kilometers across. That's 2/3 the diameter of Earth. What confuses astronomers is that although the phenomenon looks like a hurricane, it doesn't behave like one. Saturn is also the only planet in the solar system that's less dense than water. In other words, if you found a bathtub huge enough to fit this gas giant, it would float there like a rubber duck. Earthquakes on the moon don't occur as often as on our planet, but when they do, it happens closer to the center of the satellite. Scientists think moonquakes might be caused by the gravity of Earth and the sun. One of Saturn's moons, Iapetus, has bizarre two-tone coloring. The difference between the moon's 2 hemispheres is great. One of them is light, and the other is eerily dark. Scientists haven't figured out this mystery yet. The only asteroid belt in the solar system astronomers know about is between Mars and Jupiter. There are thousands of asteroids in this area. They're irregularly shaped solid objects of different sizes, but all of them are way smaller than a planet. Scientists have analyzed the chemical content of some meteorites found in the Sahara Desert, Antarctica, and other places. Some of the rocks turned out to have a Martian origin. Others arrived from the moon or the asteroid belt between Mars and Jupiter. Oh, space rocks. So we can also say space rocks. Yeah, we could say that. Space travel has come a long way since Sputnik was launched into orbit in 1957. Since then, we've sent humans to the moon, set up the International Space Station, and even sent robot spacecrafts to explore other planets. But there's still lots more to discover and achieve in space. So what are our current plans? What technologies are we developing now? And what awaits humanity in the next 100 years? Let's find out, shall we? First of all, artificial intelligence. Fun fact: my high school history teacher claimed this is what I had, as per my test scores. Right now, humanity is actively engaged in the development of artificial intelligence, and we've already made a bunch of breakthroughs in this area. With the help of AI, we're going to be able to explore the cosmos like never before. Think about it. AI can automate and optimize tasks like mission planning and data analysis. Now, human astronauts can focus on more important things, like looking for some non-human astronauts. Plus, AI can control and operate spacecraft remotely, reducing the need for risky human missions. And that's not all. This super smart technology can also provide unique perspectives and insights. AI could also help us understand the data collected by space probes. In short, the use of AI in space exploration will help us learn more about the cosmos and make exploration more efficient and cost-effective. And this isn't the only thing that will help us in conquering space. Next, reusable rockets. Gone are the days of one-time use rockets. These days, reusable rockets are taking over the space industry. Not only do they save money, but they also make space travel more accessible to a wider range of people and organizations. To date, the SpaceX company has created a bunch of reusable rockets, like the Falcon 9 and Falcon Heavy. They've completed many successful missions to the International Space Station and beyond. Blue Origin has also made great progress in reusable rocket technology with the New Shepard. It's even planning to take paying customers on trips to space soon. Alright, so these cool technologies will help us get up there. But what are we going to do next? Moving on to building settlements beyond Earth. Space colonization, here we come. The possibility of establishing colonies on other planets, such as Mars, is a dream that has captivated humans for decades, and now it's finally within reach. But before we start packing our bags, there are a few obstacles we need to overcome. For starters, getting to Mars is no easy feat. It's a long journey that could take months, if not years. So first, we need to figure out how to keep humans alive and healthy during the trip. Now once we get there, we'll face even more challenges. The harsh radiation and extreme temperature fluctuations are just a couple examples. Living and working in space isn't easy either. We need to make sure that everyone has what they need to survive. It's not like you can just go to the store for supplies, so we'll have to build systems to provide food and water, create some advanced transportation, and maintain all that in good condition somehow. Finally, let's not forget about the most important thing: money. Building and maintaining a settlement beyond Earth is no small feat, and it'll take a lot of resources and cooperation to make it happen. But there are still great benefits in living in space. It opens up many opportunities for scientific research and exploration. We'll be able to learn more about the universe and our place in it. So, no dream too big. Even though it's a big challenge, it has the potential to be really rewarding for humanity. That's why private companies and space agencies are already working on plans to send humans to Mars and potentially even terraform the planet. Actually, let's talk about that. Terraforming, the dream of turning a barren, inhospitable planet into a habitable paradise. Sounds like something straight out of a sci-fi novel, right? Well, believe it or not, by using advanced technology and resources, we could potentially turn deserts like Mars into beautiful Earth-like worlds. But here, we also have a few hurdles to jump through first. Terraforming isn't exactly a quick process. It would take a ton of time and resources to make any significant changes to a planet. There are also some ethical dilemmas to think about. If we start trying to change the Martian ecosystem, we could potentially wipe out any existing life forms. Imagine if someone did that to us. Actually, we've been doing it to ourselves. And finally, there's the cost. Terraforming would be a major expense, and it's not clear who would foot the bill. It would likely require the cooperation of multiple countries and organizations. But even with all these challenges, this is still an exciting prospect. Who knows, maybe one day we'll be able to turn Mars into the ultimate vacation spot. And that's just the beginning, because we won't stop at Mars. Our next goal is asteroids and other celestial bodies. Picture this. You're floating in your spacesuit, mining an asteroid for some seriously valuable resources. You strike gold, or rather, a shiny vein of platinum, and head back to Earth to sell it for a fortune. And with the money, you fund even more space mining expeditions, becoming the ultimate space tycoon. But seriously, space mining could be a game changer for space exploration and the economy. Imagine being able to extract water from asteroids to sustain human settlements on other planets, or mining rare minerals to use in high-tech industries back on Earth. The economic benefits could be massive. Of course, there are also challenges to overcome. We'll need to figure out how to safely and sustainably extract resources from asteroids. We also need to make sure that space mining is done in an ethical and fair way. But once we deal with all this, it will change our lives forever. So let's get to work. But once we've mined everything, what awaits us next? For example, what lies beyond our solar system? Interstellar travel and the search for life. We've already made some amazing discoveries in our hunt for extraterrestrial life. For example, NASA's Viking landers and the Galileo spacecraft have given us some clues about it. Also, in 2022, we found traces of organic matter in the former Martian lakes. We're not sure yet, but perhaps Mars was once as prosperous as Earth. But we all know that the real excitement lies beyond our solar system. Scientists have already found thousands of other distant exoplanets, and some of them are in their star's habitable zone, meaning they could potentially support life. So our next step is to send probes, or even humans there. Imagine being the first person to set foot on another planet, discovering microbial life, or maybe even a more advanced civilization. Talk about out of this world. And maybe one day, traveling to another star system will be like a regular road trip, except instead of a minivan, you're in a spaceship. And instead of stopping at a rest stop, you're stopping at a new planet. Sounds awesome, doesn't it? Right now, there are a few ideas about how we might make interstellar travel a reality. One possibility is the use of wormholes. These hypothetical tunnels in space-time could potentially allow us to travel vast distances in a shorter amount of time. It's like taking a shortcut, except instead of cutting through someone's backyard, you're cutting through the fabric of the universe. Pretty crazy, right? Another option is antimatter propulsion. This involves using antimatter, which is the opposite charge of our regular matter, as fuel for a spacecraft. When it comes into contact with regular matter, it releases a huge amount of energy. Imagine your car's gas tank being filled with antimatter instead of gasoline. That's gonna be a powerful ride for sure. Of course, there are still a lot of challenges to overcome before we can make interstellar travel a reality. But let's hope that one day we'll all be able to pack our bags and hop on a spaceship for a trip to the stars. Anyway, the future of space travel is looking bright. With all of these advancements in technology, we're excited to see what feats of exploration the future holds. There are a lot of unanswered questions in physics. How did universal energy and matter appear? Where did gravity come from? And much more. We've been trying for years to get answers to these questions, and one of the people who tried to do this was Paramahansa Tiwari, the author of the so-called space vortex theory. What is this theory, and what does it say about the hidden laws of our universe? Let's figure it out. Paramahamsa Tiwari was the former executive director of the Nuclear Power Corporation, India. He took the space vortex theory, or SVT for short, first proposed by René Descartes, and finalized it. He was always inspired by physics and its greats, even since his days as an electrical engineering student. After rigorous study of the laws of physics, he discovered new equations defining matter and the mass and charge of the electron. After that, he came up with the SVT. This theory tried to explain the unexplained phenomena in physics, including the creation of the electron and gravitational, electrostatic, and electromagnetic energy fields, as well as other things. It also described the 6 hidden laws of the universe that underlie our entire world. But first of all, let's talk about the theory itself. Space vortex theory suggests that the universe is made up of vortices, or swirling patterns of energy, and according to SVT, these vortices are the fundamental building blocks of the universe. They're the driving force behind the laws of physics and the fundamental principles of our world. Everything in the universe is connected and interconnected through these vortices. This theory isn't very based on any real observations, but rather on mathematical models and computational modeling. For example, some computational models showed how these vortices work in hydrodynamics and plasma physics. They showed that vortices in such systems can have a central point of attraction and can be interconnected. Other models were used to study how the energies inside the vortices move and how they can create different frequencies and vibrations. But some experts have criticized SVT for using only models and simulations. The biggest criticism is that this theory can't be actually tested. It relies on mathematics and not on some experimental data. That's why it's not accepted as a mainstream scientific theory. But it's still quite interesting and provides a unique perspective on the universe and our understanding of the laws of physics. For example, according to SVT, the universe has some underlying hidden rules that cause the creation of fundamental matter, their assembly, and movement. What are these laws and what do they say? Well, let's take a look at them. Law 1. The universe has only one primordial entity, space, i.e., absolute vacuum, that structures matter. This law states that space is the fundamental building block of the universe, and that it's responsible for structuring matter. It suggests that space is the fundamental entity that creates and maintains the structure of matter, and that all matter in the universe is made up of the same fundamental particles, like electrons and positrons. Let's try to put it in simple words. Imagine that the universe is like a big Lego set. Just like how all the Lego bricks are made up of the same basic building blocks, the universe is made up of the same fundamental building blocks too, and these blocks are called electrons and positrons. But what holds all these blocks together? Space, of course. Space gives it shape and structure, just like how the plastic container holds all the Lego bricks together in a set. So, the first law states that space is the fundamental building block that structures matter and holds everything together in the universe. Law 2. Matter is constituted with multiples of only one kind of fundamental particles, electrons and positrons. This law states that all matter in the universe is made up of the same fundamental particles, the electron and positron. These two are the Lego blocks we've talked about before, and according to the second law, these tiny invisible particles make up everything, from a tiny atom to a giant galaxy. Just like no matter what the shape or size our Lego build is, it's still made up of the same building blocks. Law 3. The field distribution in space, as recognized by contemporary physics, linked with and emanating from matter, are effects arising from only one fundamental field in space. This law states that the fields recognized by contemporary physics, such as the electromagnetic and gravitational fields, are effects arising from a single fundamental field in space. It suggests that this fundamental field is responsible for creating everything that we observe in the universe. So let's try to put it simple. This time, imagine that the universe is like a big playground. All the different fields we observe, such as the gravitational and electromagnetic fields, are like different games we play in there. But no matter what we play, we're still in one fundamental space. This is the playground itself. It's the base that holds everything together. According to the third law, without the playground, we wouldn't be able to play any games. And without this fundamental field in space, we wouldn't be able to observe any fields in the universe. Law 4. There is no void in space anywhere in the whole universe except at the centers of the fundamental particles of matter, electrons and positrons. This law states that there's no truly empty space in the universe, and that all space is filled with the fundamental field, the one we talked about before. It says that electrons and positrons can be found everywhere, and even the things we consider to be empty, like vacuum, are actually full of tiny particles. And according to this law, the only truly empty spaces we can find in the universe are at the centers of the fundamental particles, electrons and positrons. Law V. From only one fundamental universal constant, all the constants, considered universal in contemporary physics, are derivable. This law states that all the constants considered universal in contemporary physics can be derived from a single fundamental universal constant. It suggests that all the constants in physics are interconnected and can be explained by a single fundamental principle. I know you've been doing a lot of imagining lately, but bear with me. This time, please imagine the universe as a big recipe. All the constants in physics, such as the speed of light, the gravitational constant, and the Planck constant, are like the ingredients. They're very different, and there are tons of them. But just like how all the ingredients in a recipe are interconnected and come together to make one dish, all the constants in physics come together to make the universe. And just like how a recipe has a main ingredient that holds everything together, physics also has a single fundamental constant that holds everything together. Law 6. The spatial structure of submicrocosmic fundamental matter is repetitive uniformly in the spatial structures of macrocosmic bodies like planets, stars, and galaxies. This law states that the structure of the fundamental particles that make up matter is repetitive and uniform across all scales, from subatomic particles to macrocosmic bodies like planets, stars, and galaxies. It suggests that the same fundamental principles govern the structure of matter at all scales. Let's go back to the analogy with the recipes and cooking. Using different ingredients and combining them in different ways, the chef can create new dishes. These will all be different dishes, and they can be very simple or very complex. But when creating them, the chef still applies the same basic rules and knowledge they have, right? And just like that, the universe also creates different structures, from atoms to planets, stars, and galaxies. But it still uses the same fundamental principles to create all these things. So this law suggests that the structure of the fundamental particles that make up matter is repetitive and uniform across all scales. These are the 6 fundamental laws of the universe, according to the SVT, and even though it's not accepted by mainstream science, it's still a pretty interesting concept. Uranus is an enigmatic giant that has puzzled astronomers for centuries. But what sets this gas giant apart from the others is its strange tilt. While most planets spin on an axis that is perpendicular to their orbit, Uranus takes a wild spin in a different direction. But why does it look like this? How did the planet turn out to be lying on its side? And what would we see if we visited the surface of such a planet? Let's find out. Uranus, the 7th planet from the Sun, is a cosmic oddball and source of many jokes. It's one of the gas giants in our solar system, along with Jupiter, Saturn, and Neptune. It's also the 3rd largest planet in our solar system, with a diameter of about 49,889 kilometers. And one of its many oddities is a weird rotation on its side. Not all planets in our solar system are aligned in a straight line. While most planets in our solar system have an axial tilt of less than 30 degrees, Uranus is tilted at an angle of almost 98 degrees. It's like that one friend who always has to be different, even if it means standing on their head to prove a point. So its north and south poles are facing east and west. It's like the planet got lazy and just rolled over one day, deciding to take a nap. And why is Uranus so tilted, you ask? Scientists once thought that this was due to some kind of collision. They thought that something gigantic crashed into Uranus, something like what happened to our Earth. A dwarf planet crashed into it, the Earth tilted slightly, and the Moon was born from the remnants of the collision. But this theory had a problem. In the early universe, there were a bunch of asteroids, dwarf planets, and other large objects. And if this is so, then why is only Uranus tilted? All sorts of guys have crashed into other planets too, but they don't have such features. But recently, scientists have published a new study, and now scientists think that the culprit might be a long-lost moon that wandered away. Back in the days of the early solar system, the giant planets partied much closer together and way closer to the sun. But, as we all know, parties can get out of hand. Something caused Uranus and Neptune to migrate the farthest, like they were trying to get away from the sun's strict supervision. Each giant planet had a collection of moons, but they were constantly getting shuffled around during all this migration madness. Some planets lost moons, while others gained new ones. Uranus could have been born with a massive moon or quickly captured one, and if that moon was big enough, it could have started playing games with Uranus's spin. This moon pulled on Uranus with its gravity, making the wobbling even worse. As time went on, it made Uranus tilt more and more. Eventually, it crashed into the planet, locking it into its current tilt. While the theory is pretty sound based on computer models, we'll have to wait until at least 2030. That's when China plans to launch the Tianwen-4 spacecraft to take a closer look at Uranus and study it more. Who knows what other crazy space secrets we'll uncover next? Until then, we can all have a good laugh about the lazy rebel planet that just can't seem to stand up straight. Such a funny and unique feature makes you wonder, what exactly would we see if we were standing on this planet? How would its strange tilt affect the view from its surface? Let's see. If you were standing on the surface of Uranus, although it doesn't really have a surface, it's more like a gas atmosphere, you'd enjoy a cool view. You'd see the sun rise in the east, just like on Earth. But then it would keep going around the sky in a tilted path like a lazy spiral. About the sunset though, I hope you have some patience, because it would take 42 years for the sun to complete one full circle around Uranus's sky. That's a really long time to wait before finally going to bed. But speaking of the sky, it would be a beautiful sight to behold. Uranus is known for its stunning, unique blue-green color. It's caused by the methane gas in its atmosphere. Methane absorbs red light, giving Uranus its cold hue. You'd also see some amazing clouds and storms swirling around the planet, but if you're looking for constellations, you're out of luck. The extreme tilt of Uranus means that its poles face towards the sun, so the stars would be all over the place in the sky. The constellations that are familiar to us would be unrecognizable from Uranus. Also, as the planet rotates, the positions of the stars would change very often. For you sailors out there, good luck in navigation. But you could see its beautiful moons. Uranus has 27 known moons, with the largest being Titania, followed by Oberon, Umbriel, Ariel, and Miranda. These moons are thought to have formed from the same material that formed Uranus. And yes, the tilt affects them too. They orbit around the planet perpendicular to the planet's motion around the sun. And they aren't the only ones. Did you know that Uranus also has rings? Yep, not only Saturn is so special. The rings are made up of ice particles, some as small as grains of sand, and others as large as several feet across. They're thin, narrow, and dark compared to Saturn, for example. They're actually so black that they almost don't reflect the light. That's why it was so difficult to see them from Earth. But if you were near the surface of Uranus, you might be able to see them in the sky. The only question is, would you even be able to focus on all these views? Because Uranus is extremely cold, and that will probably be the only thing you'd think about. We're talking about temperatures that can drop down to 201 degrees. Brr, better pack some warm clothes for this trip. This is because it's so far from the sun, and its atmosphere is composed mainly of hydrogen and helium. And not only is Uranus the coldest planet in our solar system, but the winters there are long. Due to the extreme tilt, it has seasons that last for over 20 years. It's like the planet is stuck in a perpetual state of winter, which is both cool, pun intended, and kind of sad at the same time. And if that's not cold enough, Uranus is also known for its strong winds. In fact, they can blow up to 579 kilometers per hour. So, you might want to hold on tight to something, or wear a windproof suit to avoid being blown away like a leaf. And finally, Uranus's magnetic field is also tilted at an angle of 59 degrees from the planet's axis of rotation. This creates some interesting effects. The most obvious one is beautiful auroras, which are similar to the northern and southern lights on Earth. On Uranus, however, the auroras are located near the planet's equator rather than at the poles. Isn't that cool? The result is a dazzling light show that would make even the most jaded space traveler stop and stare in wonder. But even though it sounds pretty awesome, it makes it more difficult for spacecraft to navigate around Uranus. The magnetic field creates a lopsided gravitational pull that can affect the trajectory of spacecraft. This makes exploring Uranus a bit more challenging, but maybe it will change in the future. And all in all, standing on Uranus would be a chilly, wobbly, and breathtaking experience, and definitely not your average stroll in the park. Next time you look up at the night sky, think of this beautiful icy planet, and remember that even in the vast expanse of space, there is always something new and exciting to discover. More than 20 years ago, back in 1999, we discovered an interesting diamond-shaped space rock. It was an asteroid called Ryugu. Its name is the Japanese term for Dragon Palace. There's a Japanese folktale behind that name. Basically, it's about a magical palace hidden deep underwater. In this story, there's a fisherman who visits the castle traveling on the back of a turtle. He returns back to the surface with a mysterious box. About 2 years ago, a similar thing happened in reality when the Japanese spacecraft, Hayabusa, visited Ryugu and came back with mysterious samples it picked up there. And the fairy tale doesn't just stop there. There are so many craters and rocks on Ryugu, so it probably had quite a rough past. And the craters all share a theme. They're named after something from the world of fairy tales. For example, the name of the princess who lived in this magical Ryugu castle, together with her dad, a dragon deity. Some got names after the fisherman who saved a turtle, and the turtle itself, of course. But back to the science now. So, this spacecraft took a sample from the surface of Ryugu, got back to Earth, and teams of researchers discovered something really cool. This asteroid is even older than our solar system. The spacecraft took the sample to help researchers to understand the origins of our solar system better. But this is not the first time scientists came across such ancient grains. They previously found them in multiple meteorites. Meteorites are generally space rocks that survive the fall through the atmosphere to land on Earth. They're usually rich in carbon, just like the asteroid Ryugu. But the material on Ryugu is even more specific, and something you can't stumble upon on our planet: silicon carbide, a combination of pure silicon and pure carbon. The material Ryugu is made of is so unusual it even tells us the asteroid was formed in the outer solar system. It's one of the 3 asteroids, Itokawa, Bennu, and Ryugu, that are orbiting the Sun, but are moving relatively close to Earth. Each of them is just a loose pile of rubble, and their collective gravity is something that holds them together. They probably formed after their parent bodies collided and shattered into smaller pieces. Ryugu's individual rocks are probably 4.6 billion years old or even more, so it's most likely made up of material from its parent body, but some theories claim its surface could be 158 million years old. Ryugu sneaked into the inner part of our solar system, so we got a better chance to study it a little bit. It's circling around the Sun somewhere between our home planet and Mars. It crosses Earth's orbit from time to time, which is why it ended up in a category of potentially dangerous things for us, even though it's peaceful at the moment and it really doesn't harm us in any way. It's one of the darkest space bodies in our solar system, and it's surprisingly dry. Strange, its parent body probably consists of lots of water ice. Maybe Ryugu is dry because it has flown too close to the Sun sometimes in the past. That heated up its surface and dried it out, or some of its radioactive materials heated the asteroid and removed most of its water. How do we even know how old our solar system is? Once upon a time, which is billions of years ago, in some faraway, almost forgotten corner of the Milky Way, there was a molecular cloud. It fell apart and collapsed like many others across the universe did. That's how new stars form. This one formed new stars too, and one of them was a little bit isolated from the others. It collected material around it and turned it into something we call a protoplanetary disk. That's a disk of gas and dust that rotates and goes around the core of what will later become a solar system. That disk can develop into celestial bodies too, like asteroids and planets. But this disk formed the central star we today know as our Sun, 8 planets, and the rest of the objects that make our solar system. It's about 4.6 billion years old. All stars come from this pretty cool thing called a pre-solar nebula. It's once again a cloud of dust and gas that pulls material in. Later, a star forms out of it. A big outer region that surrounds a nebula is cold. A pre-solar nebula creates a protostar. It's a young star that is still not on its own, but needs to gather mass from its parent cloud. Then the star becomes independent. The material from the outer cold region then starts forming bigger clumps. As time goes by, these large clumps grow and fall in. They move around, interact with each other, and sometimes even merge or eject one another. After hundreds of thousands to even millions of years, once there's a star, the planets start forming. There were probably many objects that are gone by now, but our solar system doesn't look very different from what it was back then when it formed. Some things may have been different though. We have 4 gas giants now: Jupiter, Saturn, Uranus, and Neptune. Maybe there might have been a 5th one too. It's possible our 4 gas giants were closer to the Sun, but they migrated outwards. And what was between Venus and Mars? One theory says Theia, a smaller Mars-sized world that later, bam, collided with Earth and we got the Moon. Checking the materials of these objects, scientists have found out many interesting things when they study all kinds of minerals, rocks, and solid bodies. The composition of different elements tells them about how old some object is. They have studied meteorites that have landed on our planet. They assumed these meteorites and the Earth are part of the same system, so they calculated their potential age and got about 4.4 billion years. Rocks from the Moon haven't gone through the same processes as Earth rocks, and they're younger by a couple of million years. And the Sun, the central star of our solar system, could be a bit older. Maybe tens of millions of years older than the oldest rocks. That's how formation in most cases goes, remember? Stars first, then planets, and other solid objects next. So yes, it could be close to 4.6 billion years old. Jupiter's satellite Callisto is, as far as we know, the oldest moon both in our solar system and the universe. It's not that glamorous, just a rocky world with ice covering its surface and many craters. These craters tell us that many random flying objects have been hitting it over the past 4 billion years. That's how long we believe it's been around. Callisto and the rest of the moons around Jupiter have probably been born out of debris that was left after Jupiter formed. This all seems so old, but universe is 13.7 billion years old, so imagine how many things out there are even older than our solar system. But now, scientists have confirmed they have found one of the oldest, but also most distant objects we've ever known in the universe. It's a galaxy, Geo9 83808, 12.8 billion light-years away from us. It started forming within the first billion years of the universe, which also means it was that long after the Big Bang started everything. During the first 400 million years after the Big Bang, it was most likely way too hot for anything to form. So first galaxies, black holes, and stars started forming maybe within the first 500 million to 1 billion years. So this old galaxy could be one of the first things that ever appeared in the universe, and we get to see it. It's hard to observe it though. Scientists use a telescope to explore it, but the picture's still very blurry. It's hard to see such objects because of all those thick, gigantic clouds of dust that surround them. The Hubble Space Telescope is usually best to view distant galaxies, but there's another telescope, LMT, with a better position to look at such objects, and we can't wait for it to be fully operational to see what else it'll discover.
No one will hear your cry in space, or something like that. We've all heard this famous chilling phrase. And it's actually true. Space, for the most part, consists of a giant nothingness. There's a lot of, space in space. But this doesn't mean that there are no sounds in space. In fact, there are plenty of them. And some of them can even make you shiver. Let's take a look at the scariest space sounds. First of all, how are cosmic sounds even recorded? Sound is just the vibration of molecules. When you scream, you make the molecules push each other furiously until they reach the ear of the person you're yelling at. Then these vibrations get transmitted to the brain, and we recognize them as something that you might need to apologize for. In other words, to hear something, we need molecules, and that's where things get complicated. There aren't any of them in space. The entire universe almost completely consists of vacuum. No, not a Hoover. Absolute nothingness. However, the wizards from NASA still record space sounds somehow. How do they do it? The thing is, there are some types of waves that don't care about molecules. We regular folk can't perceive them without some special devices. These waves include, for example, radio waves. We'll need a radio or something like that to recognize them, and that's exactly what NASA's satellites do. They catch random radio waves. Thanks to their heroism, we can find out how different cosmic bodies sound. These satellites record a variety of waves, fluctuations of plasmas, magnetic fields, and other stuff. And then scientists from NASA transform all this into normal soundtracks. And some of them sound quite frightening, to put it mildly. Let's take our magnetic field, for example. It surrounds our planet like an invisible shield, protecting us from all sorts of nastiness, like radiation or solar winds. At the same time, we can neither see it, nor feel it, nor hear. Oops, the last one is outdated. Scientists from the Technical University of Denmark took magnetic waves recorded by the ESA Swarm satellite. They converted them into an audio track, and got a pretty creepy result. To be honest, it sounds more like an eerie entity stalking you in the middle of the night. And if you remember the maps of the Earth's magnetic field, it starts to feel like a spider crawling nearby. Brr. And this isn't the first strange sound that we caught on Earth. Recently, we caught another weird radio emission from space. Scientists found out that the repeating signal came from somewhere very far away, like billions of light years away from us. Such fast radio bursts usually lasted no longer than a few milliseconds, but this one was unique. It lasted about 3 seconds, basically thousands of times longer than usual. And at the same time, the signal was very precise. So much so that scientists even compared it to a heartbeat. Scientists believe that this signal is caused by pulsars or neutron stars. One time, Nikola Tesla caught something similar. But unfortunately, at that time, we didn't know about such things as pulsars. So Tesla was sure that he had caught a message from some extraterrestrial life. It's a pity that the truth turned out to be much more boring. But let's move on from the Earth to the Moon. In 1969, the astronauts of the Apollo 10 mission, the spacecraft that made the final test flight to the Moon, flew past its surface. And then they caught some strange signals coming from the dark side of the Moon. The side that we never see, because the Moon is tidally locked to us. The sound was so weird that the astronauts weren't even sure whether to report it to NASA. They were afraid that they wouldn't be taken seriously, and maybe even not allowed to participate in the next space missions. Here's what it sounded like. But, according to NASA, it's not some creepy extraterrestrial music at all. These may be just some radio waves that affected each other because of their proximity. Although the astronauts who heard it for the first time probably felt a little creeped out. Let's move to the other planets. 40 years ago, scientists actively explored the surface of Venus. They sent as many as 10 probes there, which were supposed to capture audio and video shooting from the surface. Now we know what Venus, which could easily destroy us at any attempt to even get close to it, sounds like. Horrifying. And you wouldn't expect anything else from the most dangerous planet in the solar system. Unfortunately, Venus is even more toxic than the average Twitter user, so these probes didn't last too long. They heroically arrived on a planet and soon broke down. Next one is Jupiter. This space giant, which is 11 times larger than the Earth,
never fails to scare us. One of NASA's probes, Juno, flies around Jupiter every few weeks. The probe is moving at a tremendous speed, 130,000 miles per hour. One day, Juno caught one of the strongest invisible signals it had ever encountered. This was the point at which the mad solar wind came into conflict with the magnetic field of Jupiter. It kinda sounded like a cosmic boom. The original sound lasted 2 hours, but it was compressed to a few seconds. It actually sounds more like a collision of a sea wave with a rock. But here, in terms of horror, Jupiter, surprisingly, loses to one of its small moons, Ganymede. In 2021, the Galileo space probe flew past Ganymede, and during its flight, it received a rather strange recording. These sounds are satellite radiation, and it's unclear whether it sounds like a cozy sunny day in the jungle or like thousands of bats waiting for you in the night. Next one is Saturn. This signal was caught by the Cassini-Huygens Automatic Interplanetary Station, which was launched into space in 1997. When flying past Saturn, Cassini recorded a pretty scary sound. This terrifying cry of thousands of souls is actually just some radio waves. They aren't too different from what the auroras emit on Earth. A little later, Cassini received another recording, the sounds made by lightning and thunderstorms on Saturn. They sound pretty interesting too. More like popping popcorn or a Geiger counter, right? But that's just because these lightning strikes have a crazy frequency. Moving on from the solar system to outer space. The famous Voyager 1 was launched back in 1977 and continues to send us data even 40 years after its launch. In 2012, it left the solar system and entered interstellar space. And then, while abandoning its home, Voyager 1 detected the sound of plasma waves. The original recording lasted 7 months, but fortunately, scientists felt sorry for us and reduced it to 12 seconds. It isn't really eerie, but is still kind of unsettling. And although it feels like nothing can beat Saturn's horrors, let's end this tournament with one of the scariest objects in the universe, a black hole. This sound was recorded by the Chandra Space Telescope. While studying a cluster of galaxies in the constellation Perseus, they discovered something strange. Some undulating movements appear from the center of the cluster. They spread out in all directions, like circles on the water. Scientists have suggested that this was caused by a supermassive black hole. The thing is, black holes don't always devour space objects entirely. Sometimes they kind of spit them out. This causes vibrations of gases, which we can convert into soundtracks. What's interesting is that the oscillation of each such wave actually lasts about 10 million years. You're just listening to a very accelerated recording. Scientists have reduced the delay between oscillations by about 144 quadrillion times. So, let's check it out. This is probably the eeriest sound from the whole list. Nothing too loud or wild, but there's something dark and disturbing about it. Those were the scariest space sounds captured by NASA. To be fair, most of them sound creepy simply because they're radio waves, but it's still fun to get spooked sometimes. These eerie objects are called quasars. They're some of the brightest and most powerful objects in the universe. They lurk in the depths of space, consuming entire galaxies with their insatiable hunger. Muhahaha. But what are quasars? Where do they come from? And most importantly, are they dangerous to us? Come on, let's find out. Picture a supermassive black hole, a cosmic monster so massive that it can swallow entire stars and bend the fabric of space and time. Usually, there's such a black hole in the center of every galaxy. That includes our own Milky Way galaxy. Ours is named Sagittarius A star. Sounds like the name of a hipster coffee shop, but in reality, it's a terrifying celestial body, which is 4 million times heavier than our sun. You could even see it online. For the first time, we took a photo of this black hole in May 2022. But don't worry, even though it's supermassive, it's not going to swallow us up anytime soon. This black hole is relatively small, and it's too tiny to eat an entire galaxy. So it's more like a cosmic vacuum vacuum cleaner that sucks up stars or gas that get too close. But there are black holes in the centers of galaxies that are way heavier and more dangerous than ours. They can weigh millions or even billions of times more than our own sun. Now imagine one of these monsters. Usually they're surrounded by a swirling, glowing disk of gas and dust, like water swirling down a drain. It's called an accretion disk, and it's where the magic of quasars happens. As material from the accretion disk falls towards the center, it heats up to millions of degrees, releasing vast amounts of energy in the form of radiation. And this radiation is what we observe as a quasar. So basically, the more material a black hole can consume from its surroundings, the brighter its quasar will be. This is what makes them so bright and powerful, shining like beacons in the night sky. And just imagine, some black holes can actually make entire galaxies their meal. Now, combine their ravenous appetite with some intense radiation, and you'll get a truly awe-inspiring display of cosmic power. No wonder we can see them, even though they're some of the most distant objects in the universe. Quasars were discovered in the late 1950s by accident. Astronomers were just chilling and looking at the sky when suddenly they stumbled upon something strange: radio signals that had no visible source. By 1960, hundreds of these strange objects had been found. Astronomers named them quasars, short for quasi-stellar radio source. These objects were small and far away, but their energy output was immense and difficult to explain. Some thought that these were new types of stars. Others even proposed wild things, like quasars being made of antimatter or being the end of a wormhole. But all these theories were discarded. A scientist named Martin Schmidt was the first one to get to the truth. However, many astronomers didn't believe him. Schmidt had to do a lot of extra work and gather lots of evidence to prove his theory. And finally, he prevailed. That's how we discovered quasars. Don't you love the scientific method? And since then, astronomers have been captivated by these objects. Why? Because they have some pretty eerie qualities. You could call them quasi-quasars. For example, they kind of defy the laws of physics. They emit jets of particles that travel at speeds close to the speed of light. These particles move so fast that they can even distort the very fabric of space and time. But sometimes, they help us confirm the laws of physics. Imagine driving a car. As you drive, objects in the rear window start to appear smaller and smaller until they disappear from view entirely. That's exactly what happens with quasars, except they're moving away from us at incredibly fast speeds, up to 90% the speed of light. Wonder why they're trying so hard to sprint away from us. But in any case, this helps us confirm that the universe does expand for real. Another eerie thing about quasars is that they're incredibly old. Some even date back to the time when galaxies were forming, or to the birth of our universe. Additionally, quasars are some of the most distant objects that we can observe in the universe. Some of them are located billions of light years away from us. This means that when we observe a quasar, we're actually seeing light that was emitted billions of years ago, when the universe was much younger and different than it is today. And that's why they work like cosmic time capsules. Studying them gives us a glimpse into the distant past. You see, galaxies are like giant cities, with stars and planets serving as the inhabitants. But just like cities evolve over time, galaxies also undergo changes as they age, and that's where quasars come in. They are like the urban planners of the universe. They shape the galaxies through their powerful gravitational influence. By eating galaxies and releasing intense radiation, they can trigger star formation and shape the structure of the galaxy itself. It's like the cosmic equivalent of a master chef or a leaf blower. You pick. For example, let's take galaxy mergers. Picture two massive entities coming together, swirling and spinning around each other. As they get closer and closer, their gravitational pull becomes stronger, and they start to merge into a new, bigger galaxy. It's a beautiful and dramatic process, one that can take millions of years to complete. But all this doesn't go without consequences. The gas and dust within the galaxies collide, creating massive shockwaves that trigger the birth of new stars and even supermassive black holes. And this is where quasars come into play. Some quasars may be born during these galactic get-togethers, And thanks to this, they help us study the effects of this process and the evolution of galaxies over time. But it's not all serious science and no fun. For example, how about gravitational lensing? Now, that's something straight out of a sci-fi movie. It happens when the gravity of a massive object, like a quasar, bends the path of light from a more distant object, like a galaxy, behind it. It's like having a really big magnifying glass in space. When you combine a quasar with gravitational lensing, you get some seriously awesome cosmic eye candy. The result is kinda like a funhouse mirror, where objects appear warped and twisted in strange and mesmerizing ways. Oh, so that's what happened to me. Gravitational lensing isn't just for show. It's also a powerful tool for astronomers to study the distribution of dark matter and the structure of the universe. And that's not all. Some scientists have proposed that quasars could help us to build the map of the universe. They can work like giant neon road signs. Turn left at the quasar and you'll reach your destination. They're like lighthouses that help us navigate through space. By analyzing the light from different quasars, astronomers can determine the distances between them and create a 3D map of the universe. And the best part? Quasars are located throughout the entire universe. That's why this cosmic map can give us a comprehensive view of the universe on a scale that was previously unimaginable. Who knew that a giant galaxy eater could be so useful? There is still a lot we don't know about these mysterious objects. In 2007, a team of astronomers made an astonishing discovery: the first true binary quasar. Basically, this means two huge quasars spiraling around each other. What's more, they were hiding in plain sight. For years, scientists had known about this radio source, but had never realized that it actually comes from one lovely couple. The astronomers also estimated that this pair may have a mass of about 100 billion suns. They're super distant though, at an astounding 12 billion light years away from our blue planet. Overall, quasars are a fascinating and complex phenomenon that continues to baffle and intrigue scientists. They may be cosmic galaxy eaters, but they're also playing a critical role in the formation and evolution of the universe. And who knows, maybe one day they'll become one of the keys to unlocking the mysteries of our universe. Oh, you crazy quasars. Stargazers, come up here, cause I have exciting news. Astronomers have just completed the full mapping of two pairs of stars outside our Milky Way galaxy that are chowing down on their stellar neighbors. Not only does it give us a better understanding of stars in general, but it can also help us measure distance in the night sky. Did you know that more than half of the stars in our Milky Way are paired? And while it's likely that other galaxies have a significant number of binary stars too, they're usually too faint to see. But these so-called symbiotic stars, where one star consumes the other, are extremely bright and easier to observe. And according to scientists, measuring the orbits of these symbiotic star systems is an essential step toward learning whether other galaxies create binary stars, like those in our Milky Way. Now, let's get down to the nitty-gritty. A pair of stars may be born together, but due to their masses, they age differently. The more massive one burns through its material faster, reaching the end of its lifetime first, and leaves behind a compact white dwarf. White dwarfs are small and dim, but can pack the mass of the sun into an object the size of Earth. If close enough, their gravity can pull material from their companion, creating a signal that astronomers can identify from far away. Draco, C1 and Lin 358 are the symbiotic stars that have been fully mapped. The stars in Draco C1 take roughly 3 Earth years to orbit one another, while Lin 358's components take just over 2. These are the first full orbital measurements of any symbiotic star system outside the Milky Way. The new measurements will help astronomers better understand star formation in other galaxies. In some symbiotic stars, the white dwarf can slurp enough material from its companion that it explodes in a supernova. These supernovae are incredibly bright and can be seen across the universe. They all start out with the same brightness for a nearby observer, making them like a sort of standard candle for measuring the universe. While Draco C1 and Lin 358 are unlikely to explode as supernovae anytime soon, understanding how they work can provide us with a better understanding of how these standard candles evolve. If you're here to complete your knowledge of weird stars in the universe, don't be disappointed. We're not finished just yet. Have you ever wondered about the biggest stars in the universe? Scientists have recently discovered a gigantic star called Uy Scuti. This bad boy is located about 9,500 light-years away from Earth and is truly out of this world. It's about 1,100 times larger than our Sun, which means if it were in our solar system, it would reach past Jupiter's orbit. There's more. Uy Scuti isn't just massive, it's also super bright. It's what scientists call a red supergiant, and it shines with a brightness of about 340,000 times that of our Sun. If you're thinking about getting a tan from this star, think again though, it's way too far away for that. How does a star like Uy Scuti even form? You might wonder. Well, it starts out like any other star. A cloud of gas and dust collapses under its gravity and starts to heat up. Eventually, the temperature becomes hot enough in the core of the cloud to ignite nuclear fusion, and a star is born. But Uy Scuti didn't stop there. It kept devouring more and more gas and dust, growing larger and larger. This process continued until it became the giant we know today. As fascinating as Uy Scuti is, it's not the only big star out there. There are others like Vy Canis Majoris, Canis Majoris, which was once thought to be the biggest star until Uy Scuti stole the show. Vy Canis Majoris is still a force to be reckoned with though. It's about 1,400 times larger than our Sun and located about 5,000 light-years away from us. But here's the kicker. Stars like Uy Scuti and Vy Canis Majoris aren't even the biggest things in the universe. Not by a long shot. There are objects called hypergiants that make these stars look like ants in comparison. One such hypergiant is Stephenson 218, located about 20,000 light-years away. It's about 2,150 times larger than our Sun and shines with the brightness of 7 million suns. And just when you thought things couldn't get any crazier, there's a mysterious object called the Great Attractor that's pulling everything in our local group of galaxies towards it. We don't know what it is or what's causing it, but one theory is that it's a massive cluster of hypergiants. We'd be minuscule in comparison. This next star is so metal, it's practically headbanging all the time. Jokes aside, scientists have discovered a star that's called a heavy metal subdwarf. It's a type of star that's seriously metal heavy. This star has more metal in its composition than any other star we've seen before. Such stars are said to contain metal elements like iron, nickel, and chromium. This heavy metal subdwarf has about 10,000 times more iron than our Sun. In their discovery, astronomers used a technique called spectroscopy, which involves analyzing the light that comes from the star to determine what elements it's made of. By looking at the spectrum of light, scientists were able to see that this star had an unusual amount of metal in its composition. There's more. This heavy metal subdwarf isn't just a regular star with a lot of metal, it's also really weird in other ways. For one thing, it's smaller and cooler than our Sun, and for another, it's really old. We're talking about a star that's been around for almost as long as the universe itself. What does this all mean? Well, scientists are hoping that by studying this heavy metal subdwarf, they can learn more about the early universe. Since this star is so old that it was around when the universe was just beginning to form, it's seen a lot of stuff. By studying its composition and characteristics, scientists can get a better understanding of what the universe was like in its early days. This next star is one of the coolest things in outer space. Her name is Vega, and it's one of the brightest stars in the night sky. Some recognize it as the shiny point of light in the constellation Lyra-Lyru. And get this, It's only about 25 light years away from us, which in astronomical terms is practically next door. Scientists have been studying Vega for a long time, and they've learned some pretty interesting things. For starters, Vega is a young star, only a few 100 million years old. That might sound like a long time, but compared to our Sun, which is around 4.6 billion years old, Vega is practically a newborn. Vega is also a very hot star, with a surface temperature of around 9,400 degrees Celsius F. To put that into perspective, the surface of our Sun is only about 5,500 degrees Celsius. So, if you think it's hot outside today, just be glad you're not hanging out on Vega. Another interesting thing about this star is that it's surrounded by a disk of dust and gas. This disk is called a debris disk because it's made up of leftover material from when the star formed. Scientists think that this debris disk is similar to the one that surrounded our solar system when it was young. Vega is also a source of cosmic rays. These rays are high-energy particles that zip around space at incredible speeds. They're made up of protons, electrons, and other particles, and scientists aren't exactly sure where they come from. But they do know that Vega is one of the places where cosmic rays originate. But wait, there's more. Vega is also a famous star in pop culture. It's been used in a lot of movies and books as a source of inspiration, mostly because of its brightness and cool features. The hunt for interesting exoplanets and life forms somewhere out there in the vast expanse of the universe keeps going. No stopping here. We're basically searching for a second Earth, a planet that's similar to our home, and where we could finally find some space friends. We're not picky. Any form of life is fine, even some bacteria-sized organisms. And this search has mostly been going on in the habitable zone around other stars. We also call this the Goldilocks zone. That's a region where conditions are barely just right for liquid water to exist, whether we're talking about the surface of a planet or a moon. The hotter the star, the more space we get to explore, because its habitable zone spreads far away. And in terms of endless space that we yet know so little about, that's a lot of work. That's why we're fans of red dwarfs. There are hundreds of billions of stars in our galaxy, and probably around 80% of them are red dwarfs. These tiny stars are much cooler than our Sun. It means that their habitable zones are much smaller and closer to the star, so we know better where to look for planets. They're circling around their central star, and at some point, bingo, there it is. They pass in front of it and block out some of its light. The Kepler Space Telescope has already helped us find thousands of planets using this method, and most of them are orbiting around red dwarfs. Some of these planets are similar in size to Earth, and many of them could have nearly 25 times more water than our entire planet. Let's move to these planets scientists discovered though. I want to show you something special. So you've heard of super-Earths, right? More massive than Earth, lighter than Neptune, can be made of rock, gas, or a mix of both. Some of them have thick atmospheres, while others have thin or no atmospheres at all. You may have also stumbled upon mini Neptunes by now too. They're almost as big as Neptune, and unlike normal gas giants, they have solid cores. That way, they can support a dense atmosphere with water and some other chemicals necessary for life. There are also hot Jupiters. Those are pretty cool, but only if they're far away from us. You know that one annoying and unpredictable neighbor you can never get rid of or figure out what they are going to do? Yeah, that would be a hot Jupiter, with strong gravity that can destabilize the orbits of smaller planets or other space bodies in the system. If we had such a neighbor, there would be more comets and asteroids hitting our surface. Luckily, our Jupiter's a good and peaceful neighbor that minds his own business, at least for now. But let's leave all these and many other planets out there alone now. Imagine traveling around in your spaceship and coming across a giant eyeball just floating there in the darkness of space and staring at the central star of that solar system. It's not a monster. Hopefully, space friends we'll make in the future won't look that big and scary. so it won't blink or turn toward you as you come closer. It's actually a planet, a little bit bizarre but still very cool. And yup, you guessed it right, we call such eyeball planets. Eyeball planets are surprisingly common. Plus, some normal planets can potentially turn into them too. Eyeball planets form when matter and dust accumulates around a star and gradually turn into a solid object. It starts spinning, and over time, the gravity of the star pulls on the planet and slows its rotation until it becomes tidally locked. That means one hemisphere always faces the star, while the other is in darkness all the time. We have a good example of this phenomenon near us, too. Our moon makes a circle around Earth once a month. It takes the same amount of time to turn a single time on its axis. That way, we actually always see the same face of the moon. Who knows, maybe the other side is even prettier. If you know, you like craters and stuff. So, one of the most interesting things about eyeball planets is their appearance. If they had water on their surface, the side facing the star would have clear, bright blue oceans, the ones we'd want to visit if we ever got a chance to go on an interstellar vacation. And the other side would be more for adventurers who like harsh and challenging surroundings. Since it's in constant darkness, it would most likely be very cold and covered in ice. We've discovered so many planets outside of our solar system in the last 30 years. Super-Earths are, of course, especially interesting. It seems that many of them are not that pleasant since they're pretty hazy and cloudy. It means it's harder to spot any life there. But some scientists still think they're promising spots when it comes to finding life beyond our solar system. Eyeball super-Earths would be a good start. These planets are probably covered in large oceans. On the cold half, where the eternal night reigns, you'd experience Arctic conditions. Brr, I feel cold just looking at this, but the day side is my jam. Plus, it sounds promising when it comes to finding life, you know, with all that sunlight, oceans, and stuff. One of the good examples where scientists are looking for life is an eyeball super-Earth that lies in a habitable zone of the closest star to our solar system, called Proxima b. Its day side could even have conditions and an atmosphere to support some form of life. There could be a large, deep ocean covering its surface. It could be really salty, but some forms of life could still survive there. Check out the Dead Sea on Earth. It's extremely salty, but some bacteria have still evolved to live there, and they're probably doing well, having their own world and all that. I mean, it's not crowded because there are no animals there. Fish that accidentally end up in the Dead Sea won't survive there for long. So, similarly, it's possible that bacteria or some other forms of life could exist in this potentially very salty ocean on Proxima b as well. But the open ocean on Proxima b could be tricky. On the dark side of the planet, the ocean could freeze, and sea ice could drift into warmer waters. That way, the ocean would cool, and more of it would freeze, even on the sunny side. The only way to prevent this global freeze-over would be an atmosphere with a lot of greenhouse gases like carbon dioxide. This kind of atmosphere would trap the heat from the planet's surface and wouldn't allow it to escape into space. Like what happens with Venus, the hottest planet in our solar system. Without an atmosphere with greenhouse gases, the surface of Proxima b would be much colder, so it's possible that the planet would completely freeze over. The opposite scenario could also be possible. Warm waters could serve as a transporter of heat from warm to cold regions. We don't know much about the conditions on the planet yet, so Proxima b could range from a frozen wasteland to a hot, hazy world, depending on many factors. So yeah, an eyeball planet within the habitable zone sounds promising, but its surface can still wildly range from a frozen desert to an endless ocean. Some experts believe that drifting sea ice might cool many exoplanets out there, and they can't turn into eyeball worlds. Instead, many just become sad, dark snowballs, completely covered in ice. A cool spot to spend your interstellar winter holidays, but not a place where you'd hope to find life, unfortunately. Some studies show that even Earth may have gone through some snowball stages many times in history. One of those happened around 2.2 billion years ago, while the other one hit the planet 630 million years ago. During these phases, all of our beautiful oceans were covered with snow and sea ice. Perhaps even the continents were just thick ice sheets, at least on the surface. Alright, enough with the freezy, icy stuff. I need some hot chocolate. From where we stand, the sun seems so calm and peaceful. But like humans, and basically the whole living world, the sun has its own phases when it's more or less active. It's just that the consequences are way bigger and more chaotic when the sun becomes hyperactive. Let's zoom in to see what's happening up there. So, one of the ways we measure the activity of our star is by counting sunspots on its surface. Sunspots are dark patches that form when the sun's magnetic field gets all tangled up. It's simple. The more sunspots, the more active our sun is. And it seems the sun has been partying like crazy recently. The number of sunspots scientists have seen is the highest for nearly 21 years. In June, 163 sunspots appeared on the sun's surface. The last time we had so many dark patches across the sun was in September 2002, when there were 187 of them. It seems this chaotic party is getting closer to its peak, and that's something we call solar maximum. How does all this even happen? The sun's magnetic field is strong and organized at some point. But as we said, sometimes comes the time when it kinda ends up tangled, sort of like a ball of rubber bands that are wound together very tightly. This also means plasma is rising from the surface, forming loops, and causing a mess in the shape of solar flares, and something we call coronal mass ejections, CME. That's when plasma in the sun's upper atmosphere called the corona goes crazy and bursts really strong. Then at some point, this ball snaps and completely flips and turns the South Pole into the North Pole and vice versa. All this happens every 11 years or so. So when the sun comes into this phase when it becomes very active, it shoots out hot blobs of plasma, gets big dark spots as large as planets, and releases powerful eruptions of energy and radiation. Something fascinating happens when the sun becomes more active, a thing called plasma waterfall or polar crown prominence. PCP. It's like a mini eruption that starts on the sun, and it seems like it tries to get away, but then the sun's magnetic field pulls it back before it can escape into space. And this plasma waterfall is really spectacular. It goes up to 62,000 miles above the surface. It's like you stack 8 Earths on top of each other. Then, there's something called a polar vortex. It's like a gigantic halo of plasma that rotates around the sun's north pole really fast. This vortex happens when a large tentacle of plasma snaps apart and falls back toward the surface, similar to how a plasma waterfall forms. Scientists don't know why this plasma stays above the sun's surface for so long. And one of the cool examples of CMEs was a giant one in the shape of a butterfly in March this year. It got such an unusual shape because it exploded on the side of the sun we couldn't see, so it was impossible to fully measure how strong it was. Fortunately, that one didn't explode in our direction, but it might have hit Mercury a little bit, and it's possible it knocked off some dust and gas since Mercury has a weak magnetic field. All this sounds cool in theory, but it's not such good news for us. Because of all this, we might experience more intense solar storms that can, again, lead to geomagnetic storms on Earth. And these don't just sound alarming, they indeed are. They create chaos and disrupt the magnetic field of our planet. Geomagnetic storms can create beautiful northern lights, true. But we'd all rather enjoy such beauties as the aurora borealis in regular conditions, or just watch a good old sunset above the ocean. It's not that every solar storm will necessarily hit Earth, even if there are more of them. To reach our planet, they must be pointed in the right direction at the right moment. But if that happens, the storm can ionize the upper atmosphere, and bye-bye our communications. It can cause temporary blackouts for systems such as GPS and radio. It isn't necessarily a big problem on its own, but it can be very dangerous if it happens at the wrong time, like during a tsunami or an earthquake. The storms can also damage electrical infrastructure like rail lines and power grids. If you're on a plane at that time, you might be exposed to higher levels of radiation. It's still not clear how dangerous that will be for you, but it can be a serious problem for astronauts in space. When solar storms mess with the magnetic field, this can affect the migrations of some animals, such as sea turtles, whales, and birds. Since things in the animal kingdom mostly work in the natural order, who knows how these animals go through or even survive such changes? And when the sun is at a maximum of its activity, satellites in space are in trouble too. We have more satellites in space than ever before, and when the upper atmosphere becomes denser because of all these changes, this can push satellites in different directions. They might crash into one another, or some can even fall back to Earth, which again is only cool in movies with superheroes who can relatively easily deal with this stuff. Hopefully, we'll avoid a massive solar storm like the Carrington event. The story was similar. In August 1859, astronomers across the globe watched how the number of sunspots was getting bigger and bigger. A man named Richard Carrington was among them. At the beginning of September, he was sketching the sunspots when, out of a sudden, he was blinded by a flash of light. It lasted around 5 minutes, but it was spectacular. He later described it as a white light flare. It was a very strong coronal mass ejection, CME, and in only 17.6 hours, this storm crossed the long way between the sun and our home planet, 90 million miles, and unleashed its force on us, even though this usually takes days. And when this storm started, telegraph machines across the world sparked, operators got electric shocks, and paper even caught fire. People were really scared and confused because they had never seen such bright skies before. Some even thought it was the end of the world. The next day, telegraph workers still couldn't work properly because Earth's atmosphere was still charged. They even managed to send messages using the auroral current instead of regular electricity. But it brought something incredible too, stunning auroras in the sky. People in Hawaii and Cuba could see beautiful northern lights, while those as far north as Chile could see the southern lights. It's all slowly but steadily escalating. Take solar flares, for example. These are powerful bursts of energy from the sun. In 2022, there were 5 times more of these flares compared to the previous year, plus the strongest ones. X-class flares have been getting stronger and more common than before too. And this might be way more extreme than anyone thought. Plus, it's likely to start a little bit earlier than we predicted. Scientists first thought the peak would happen in 2025, but it seems it could even occur by the end of 2023. We can't completely protect ourselves if a solar storm hits us directly, but we can still do some things, like ground planes, adjust the paths of satellites in space, and try to make sure vulnerable infrastructure stays safe. To do all this, we need better solar weather forecasts to help us get ready for the worst. All this might sound very bad at first, but don't worry, solar flares won't destroy our planet. They do send charged solar material toward us at pretty high speeds, but it's not like we're completely doomed if these things hit us. Our planet won't leave us unprotected. We still have the atmosphere and magnetic field that keep us relatively safe. Our thick atmosphere is like a shield that blocks radiation that might harm us. So, these solar flares can mostly affect technology, but they won't destroy Earth. I guess we have our own superheroes after all. What do you know about the weird and wacky world of states of matter? Most of us know that matter can be solid, liquid, and gas. Some of us even know about a special fourth state called plasma. But what about the extraordinary states that behave in crazy ways, like dancing and color changing? Forget what you thought you knew about solids, liquids, and gases, because we're diving into the wild side of physics. Let's go. First, we have quark gluon plasma. This state of matter looks like a hot and soupy mess. It's a bizarre state that existed just moments after the Big Bang, when the universe was incredibly hot and dense. You see, inside all the things around us, there are tiny particles called quarks. And, as far as we know, they're the smallest particles of the universe. They're the building blocks of our world. Just like Lego bricks, they come in different types and can stick together to form bigger structures. We have up quarks, down quarks, strange quarks, charm quarks, top quarks, and bottom quarks. All of them are held together by some special forces, the gluons. They're like the super glue that keeps the quarks stuck together. They carry a special force called the strong nuclear force. They're also kinda like the messengers, passing messages between the quarks and keeping them connected. Now, how do we create a plasma out of them? Well, we need to heat things up, and we have to use some serious heat to create the quark gluon plasma. It's like throwing your pizza into a scorching oven. When you crank up the heat, the cheese starts to melt, and it becomes all gooey and runny. In the same way, when we heat quarks and gluons up a lot, like in extreme conditions, they become energetic and start to break free. All this transforms matter into a hot, soupy mess. That's how scientists can recreate this special state in laboratories by smashing together particles at high energies. But why do we even need to do that? Well, studying the quark-gluon plasma helps us understand how the universe evolved and what happened in its earliest moments. To understand the recipe of the entire pizza, we need to know all ingredients, right? Including the melted cheese. Next, we have a Bose-Einstein condensate. It's a pretty weird state of matter. Let's try to explain it like this. Imagine you have a group of friends at a party. Usually everyone dances and moves around freely, creating a lively and energetic atmosphere. But what if something strange happens? What if all your friends suddenly slow down and start moving together in perfect sync, almost like a slow-motion dance? Sounds like something out of a horror movie. But that's what happens in a Bose-Einstein condensate. It's a unique state of matter, and it occurs when certain particles called bosons get extremely cold. When this happens, all the bosons gather in the lowest energy state possible, and then they form a cool club where everyone is doing the same thing. Okay, first we take some gas with low density and cool it down to super low temperatures, close to absolute zero. It's like the coldest temperature possible. Because it's so cold, everything stops moving, including particles. That's because atoms and molecules have no energy left to move. This temperature isn't physically possible as far as we know, but we can get super close to it at about 459 degrees Fahrenheit. Scientists use lasers and special equipment to reach that state. But when it happens in a Bose-Einstein condensate, the bosons don't just become still like statues. Instead, they gather in the lowest possible energy state and kind of form a single entity. They start to behave collectively, as if they're part of one big superatom. Their motion becomes highly coordinated and synchronized. It's like the collective mind from Rick and Morty. Studying Bose-Einstein condensates helps scientists understand the strange and quantum nature of matter. It helps us to unlock the secrets of a hidden realm where the rules of the ordinary world no longer apply. Next, let's talk a bit more about quarks. These guys are so special that they get one more state of matter to themselves. This one is called QCD matter, or quantum chromodynamic matter. It's a fancy name for the theory that describes how quarks and the strong force interact. Remember how we were talking about Lego blocks? In the normal world, each block has its own color, shape, and size. But what if you could play with a special kind of Lego where the blocks change their colors, shapes, and sizes as you stack them together? That's a bit like what happens in QCD matter. Normally, quarks stick together tightly inside particles like protons and neutrons. It's like they're holding hands and can't move around much. But when things get super hot or under a lot of pressure, something interesting happens. The force that holds the quarks together, called the strong force, becomes weaker. It's like their grip loosens, and suddenly the quarks can move around more freely. This is when QCD matter appears. When the strong force weakens, the quarks start acting like they're in a fun playground. They can zoom around and interact with each other in exciting new ways, and even change their colors. It's like the building blocks coming to life and having a blast. Scientists study QCD matter in particle accelerators like the Large Hadron Collider. They smash particles together at incredible speeds and energies. They almost create mini early universes and the hearts of neutron stars in their labs. They study QCD matter to understand how quarks behave and how the strong force works in extreme conditions. This way, we can learn more about the fundamental nature of matter and the forces that hold it together. In other words, it helps us to understand how our universe is built. And finally, we get to the last weird state of matter called neutronium. Imagine you have a bunch of balls. Some are red and some are blue. They're all bouncing around, constantly colliding with each other. Now, let's take away all the red balls and keep only the blue ones. That's a bit like neutronium. Neutrons are tiny particles that hang out in the nucleus of an atom, along with protons, like a cozy group of friends. They're like the chill buddies of the atomic world. They're neutral, meaning they don't have any charge, hence the name. They play an important role in holding the nucleus together and determining the properties of different atoms. Neutronium is a substance made up mostly of neutrons, and in this weird substance, neutrons all by themselves, without any protons. It's like a neutron-only party. So, what happens when we leave them alone? Well, neutronium is incredibly dense. It's like packing a huge number of blue balls into a small space. In fact, it's so dense that a teaspoon of it would weigh as much as a mountain. Pretty crazy, isn't it? Neutronium also has another quirky feature. It's super strong. If you tried to squeeze this substance, it would resist and push back against you with a force called neutron degeneracy pressure. It's like the blue balls in our analogy being so tightly packed that they don't want to be squished any further. Scientists think that neutronium might exist in the cores of certain extremely dense objects, like neutron stars.
Black holes are some of the most enigmatic and sinister phenomena in the universe. They can swallow up entire stars and planets, bending the very fabric of space and time. But what if Earth, our home planet, were to be caught in the grip of a black hole's event horizon? What would we see before the inevitable end? Let's have a look-see, okie dokie. So, a black hole is like the bully on the playground. You avoid them at all costs. It's a region of space where gravity is so strong that nothing, not even light, can escape it. It's like Houdini in reverse. As with snowflakes, every black hole is unique. Each one has its own mass, spin, and charge. And they also come in different sizes, sort of like jeans: petite, slim, regular, and husky, or something. Anyway, there are 4 sizes. The smallest black holes are the stellar mass kind. They're born when a massive star runs out of juice and folds in on itself. They're like the chihuahuas of the black hole world. They may be tiny, but they're feisty. They gobble up nearby matter like a hungry puppy. And even the smallest one is 3 times more massive than our sun. Next up, we have the middle children of this cosmic family, intermediate mass black holes. They're too big to be born out of the collapsed stars. Scientists believe that they may be created when several black holes merge into one. And even though they can't dominate galaxies, at least they can swallow up some nearby stars. Goody for them, huh? But do you know who can dominate a galaxy? The enormous monsters of our universe, supermassive black holes. They're the giants with masses ranging from millions to billions of times that of our sun. And they play a crucial role in the growth and formation of their host galaxies. Finally, there are ultra-massive black holes. Trust me, you can't even imagine the size and the mass of these guys. These cosmic eldritch horrors are extremely rare, but the ones we know can devour entire galaxies like Pac-Man. So, what happens if you get too close to a black hole? Or more like, what would you see in your last moments? Well, first, you reach an event horizon. It's like a point of no return, an invisible boundary that marks the edge of a black hole. And here's where things start to get really weird. For example, time starts to slow down. Not for you, for an outsider watching you from a safe distance. If you were falling into a black hole, you wouldn't feel any different. But if you were watching someone else fall into it, you'd see them slow down and eventually freeze in time, like in a paused video. As you get even closer, you would start to see some pretty mind-bending things. The gravity would cause the light around you to bend and distort, creating a sort of funhouse mirror effect. You might even see a halo of light around the black hole, known as the photon ring, or jets of high-energy particles spewing out from the black hole's poles. You can actually get pretty close to a black hole without feeling any major effects. It's only when you cross the event horizon, then there's no going back. Your goose is cooked. After crossing this boundary, you'd be unable to see anything. For the person watching you from the outside, it would be as if you had suddenly disappeared.
Meanwhile, you might start feeling a bit stretched out, like a piece of spaghetti. This is because the gravity is so stark that it's pulling you in different directions at once. There's even a scientific term for it called spaghettification. We'll cover linguinification in another video. Now that you're inside a black hole, you're taking aim at the singularity. It's a point of infinite density in its center, where all matter is crushed down to a single point. It's like trying to fit an elephant into a tiny matchbox. Everything gets squished together until it's as small as it can possibly be, which means it's time to wave goodbye, I guess. And if all that sounds scary, here's another fun fact. Black holes are not rare at all. Actually, there's one in the center of each galaxy, including our own Milky Way. So, does it mean that we'll be eventually sucked into it? And if so, how exactly would it happen? Well, let's see. Imagine a black hole approaching our solar system. At first, it appears as nothing more than a tiny speck in the distance. But as it gets closer and closer, its gravitational pull begins to wreak havoc around. Planets start to veer off course, asteroids are flung into oblivion, and comets are shattered into a million pieces. But just like waiting for the sausage to be served in a German restaurant, the worst is yet to come, like that joke. Soon, it inevitably reaches the Earth. First, our planet's atmosphere would be pulled towards the black hole, triggering a massive windstorm, and there'd be huge waves on the oceans, the water itself being distorted by gravitational forces. Imagine seeing seas and oceans get stretched out. Earth's magnetic field is generated by the motion of molten iron in the planet's core. But now, the extreme tidal forces of the black hole would disrupt this motion, causing the magnetic field to weaken and distort. All this would cause massive earthquakes and volcanic eruptions. As the planet's crust and mantle were pulled apart, all infrastructure and technology would be completely destroyed. Buildings, bridges, and roads would be torn apart. Okay, let's hit the pause button. Pretty horrifying, isn't it? Nah, but don't worry. You wouldn't even have seen all that, because you would have felt the effects of the black hole much, much earlier. Back to the future. We'd lose our magnetic field even before everything started to collapse. And this means not only that the weather and climate will become terrible, we'd also be exposed to extreme radiation. These gamma rays and the heat from the black hole could drastically change our planet. Say ta-ta to all our beautiful nature. At least misery loves company. We won't be the only ones affected by a black hole, which is probably even worse. As this beast engulfed the entire solar system, it would consume about everything. One immediate effect would be the disruption of the orbits of asteroids, comets, and all the other bodies. The planets would begin to deform and stretch, their surfaces warping like molten metal. The sun itself would be affected, its surface contorting like a gob of putty. And yeah, all this is scary to even imagine. But now, breathe and relax, because none of this will ever happen. This is the bright side, remember? Your infinitesimal odds of winning the big lottery are even better that the Earth will ever be swept into a black hole. The nearest black hole to our solar system is called Gaia H1. Discovered by scientists in 2022, it's found in our own Milky Way galaxy, about 1,600 light-years away from Earth. Gaia H1 is about 10 times the mass of our Sun, which makes it a stellar mass black hole. It's not very interesting on its own, but its discovery has supplied valuable insights into the behavior of these cosmic monsters. But as you can see, even the closest known black hole is over 1,000 light-years away. They move very slowly, and they'll never get so close to our system to pose some kind of threat. Hey, but didn't you say that there's a black hole in the center of the Milky Way? Doesn't that mean it's going to eventually hoover up our entire galaxy? You may ask. Maybe not in that voice. Well, don't worry. The correct answer is no. The one in the center of our galaxy is called Sagittarius A star. You may remember it from that viral blurry photo that circled around the internet a few years ago. This black hole is indeed very massive and has a strong gravitational pull, like two 8th graders in love. However, it's still a small beam. it only affects objects that are close to it. The objects in the galaxy are all too big and move too fast to be pulled in by black holes. Nevertheless, they're still fascinating objects to study. Scientists are still trying to unlock the mysteries of black holes, and even though they'll never be dangerous to us, they're still a huge reminder of the incredible power of our universe.